Well, welcome everyone. Today we'll be discussing AWS Solution Architect access identity and access management in AWS, also known as the IAM itself. So let's jump straight in and let's start the session. Today we'll be discussing following features of IAM. We'll be discussing what are the key features of IAM. We'll be discussing AWS policies that are included and you can create. We'll be discussing what is AWS user and what kind of permissions we can assign. We will be discussing IAM groups. We'll be discussing IAM roles, as well as the best practices that we can use when using, obviously, IAM as a service itself. So let me just erase that and jump straight onto the overview slide itself. So key features of the IAM, which is the identity and access management, are: it's a shared access to your account, which means that you can create multiple users that will have access to the whole AWS account. You can have a granular permissions, as we kind of mentioned before, which means not everyone must be an admin, or in theory should be an admin. You can have secure access to AWS resources, which means you can only enable users to access whatever you think it is necessary for them to access, hence the secure access point here. You're going to have identity federation, which we're going to be discussing of different ways of accessing this and linking this to your on-prem systems. We will be discussing also multi-factor authentication, also known as MFA, so those little fobs and code devices that you can use as a secondary authentication method. We'll be discussing password policy, what kind of policies we can have and what are the default ones. We'll be also discussing payment card industry, also known as a PCI, as well as data security standards and DSS compliance, which is important, especially when you're trying to run an online sales or online stores and you're taking some sort of payment through your system, and that's exactly what we will be mentioning as well as identity information for assurance, which is basically what are the minimum requirements from maybe different vendors to actually approve AWS from security perspective. So that's pretty much what we'll be discussing. I would like to jump straight into it and start maybe with shared access. So basically, you have a right to grant permission to users to access and use resources in your AWS account, and that's important. And you don't have to share your own password with them, which means as long as you're admin, which pretty much by default when you create an account, you're en route, you can then create yourself an admin account. And then through this admin account, you can basically create different users, allocate them with the different permissions, and you can then go a little bit further. You can allocate specific users, or specific user in this case, to have access, for example, to EC2. The same user can have access to S3 bucket, but guess what? Maybe there's a user in your organization that only has access to S3, but not obviously to EC2, which you can still do. Basically, you can grant permissions to every single user or even a group to any resource you can think of, or even specific features of each single resource that you can think of. It's extremely granular, it's extremely powerful, and you can really have full control over that. So basically that's what the shared access is. I will jump straight into the second slide, the granular permissions. What it is, what it means, and how it works. Well, granular permission allows different permissions to various users to manage their access to AWS, such as user access to specific services, specific permissions for actions, or specific access to resources. Now, when we're talking granular, we actually mean that we can dedicate each user with only permissions we want them to have. So imagine, I want maybe someone to be able to access my console and only see my instances, so basically read-only instances, but not necessarily change anything. They don't have access to change a name of it. They don't have access to access the instance itself. They don't have access to pretty much anything. They can just see the instances. And the reason why we would do that sometimes is because when you have audit in your company and somebody else requests access to your systems, you will have those situations that they will come and say, hey, I want to access your systems. And you say, well, that's great. I can give you access because my boss asked me to, but I'm not going to give you rights to change anything because you don't need them, because it's a production system. Hence, I'm only going to give you read-only access, which means that they cannot perform anything of only what you gave them. In this case, obviously, access to read-only instances, and that's it. They cannot do anything else. So that's basically how granular you can go. The same applies to S3. The same applies to pretty much every single thing you can think of in AWS itself. So I'm going to jump straight to the next one. Secure access. Securely allocate credentials that applications on EC2 require to access your AWS resources. What it means is that you can basically have an application running on your AWS account, and the particular application requires access to resources sitting on the same account, like S3 bucket or maybe even a database storage. So what happens is, instead of you granting the user permission, you actually grant application a permission. You can do this via the IAM, and we'll discuss this in a few seconds. There's a difference between granting permissions to a user and granting a role, which is exactly application itself. And imagine the application itself must access S3 because it contains maybe some sort of web server file or bunch of files like CSS or images, and it must obtain those. So what we will do is we'll basically create a new IAM policy saying, hey, I want that instance to be able to access my S3 bucket, and this particular bucket that we want in order to work correctly. And that's the minimum amount of permissions that the application itself needs in order to work. And we can do that. We don't need to grant all of the permissions to everything. We only can grant whatever is needed. I have a question here straight away. Volume means it's related to S3 bucket. Yes, it is, although in the previous slide I believe that we discussed, so let me just go back. Volume in this case is actually an EBS volume. So that's a basically network drive that you attach to your instance itself. But the volume itself will have separate permissions, and you can grant permissions to instance or volume on both in the same time. So that's the granular concept in this case. So what is identity federation? Identity federation allows users with external accounts to get temporary access to your AWS resources. Well, what it is and what it means. Guess what? Very common scenario. You have Active Directory in your office or maybe in your data center. And instead of creating maybe hundreds of new users via the IAM console, what you can do is you can extend your Active Directory using the IAM via the federated identity federation. And all of those users from your Active Directory that you specify will have access to your AWS resources. And it can be easily done. And you don't need to recreate all those users, and better yet, you don't need to manage them from a few different places. As long as you manage your AD in the very good and uptime way, that means that all the users on your AD will be exactly valid on AWS itself. I see here another question, but it was but I was told earlier that instances cannot be attached to the S3 directly, but can be accessed, but can access EBS volumes. Well, that's kind of correct. By default, EBS volume is the network drive that you can attach to your instance itself. S3, on the other hand, cannot be attached just like that easily. What you'll need to do is install additional package that will allow you to basically mount S3 onto your instance or on top of your system, and then you'll be able to access your basically S3 bucket. You can actually access this via the CLI, which is the command line interface, and you can request all the files if you need to. But remember that S3 itself has a disadvantage because it's not a root device, which means the data cannot be indexed. So every single time you want to list what is inside of the bucket, you need to wait a few seconds or even a few minutes, depending on how many files you have in there, for the list of files to be generated from the bucket itself, and that's a disadvantage. So I wouldn't recommend mounting S3 directly just when you use it, but what you can do is you can actually access via CLI and fetch specific files when you need them, and that's achievable. Also, I have another question here from Ravi Babu. As we have a family of EC instances, which instance a specific user can create a policy? It doesn't matter. The IAM policy is agnostic to EC2 itself. It's basically it's a list of users that is allowed to access the whole account. It doesn't matter what instance type you have. Once you created users on your IAM, then this particular user will be able to create any instance type you want. So that's basically how you think of it. Think of IAM as an Active Directory in your office. It doesn't really matter if user exists on it or no. It means that the resources that you have within your company are independent. So the access to them is one thing, but the resources in your company are the second. So that's how it works. Another question from Chandra here. When we say extend our Active Directory, how we will do by creating another replica domain, another in AWS? Well, there is a very good tutorial on that. I can share the link with you on that. It's pretty much it's pretty simple. All you will need to do is you will need to create a forest trust on your AD level and basically expand this forest trust onto the AWS. And then you will generate basically a single file that you can upload to AWS into Identity Federation. And with this particular file, every single time that you're going to go to your single sign-on page, you'll be able to be redirected straight into AWS, and the credentials will be matched with your user, and this way you'll be authenticated. So basically, it's like this, but I will send you the details by the end of the session today, so remind me at the end of it if it's okay with you. I can see a few more questions. Can you change permissions and roles programmatically instead of in the IAM console? Yes, Otis, yes we can. You'll be able to change the permissions based on either console or CLI, which means if you remember from one of the first sessions, basically what console is a nice web interface which is actually using CLI underneath, which means every single action you generate in the console is actually converting this into CLI and you're sending commands anyway. It's just a pretty wrapper or interface in front of it, so it's easier to use. But yes, you have every single command that you can execute in the console. You can actually perform in the CLI itself. So there you go. I have actually lots and lots of questions. You know what? I would say like this. Maybe if we have all those questions regarding like very detailed ones regarding like can we maybe is it AWS Directory Service the same as MS AD service, and also we have a Unix Open LDAP and all of those questions which are very, very valid and technical. I would want those questions to be maybe in a Q&A at the end, which we'll have lots of time to discuss. So let's go through maybe a few more slides, and we're going to be doing lots of demos as well. And at the end, we're just going to go through that. I would think that's the best way forward for us. So as I said, you have different routes of authenticating. You can even use Facebook if you want, or you have a Google account to access the same way, depending on how your organization is actually authenticating against your systems. Most of the time, it's actually Active Directory because that's obviously the most common. Then you will be able to do that. But remember, it doesn't mean that you need to use any of them. It's an option, but there's no need, because most of the time when you even have an organization, maybe like 10, 20,000 people working in it, guess what? Not 20,000 people will be accessing your AWS. In fact, I can bet maybe even 5 to 10 people will be accessing the AWS out of 20,000, which means effort needed for implementing Active Directory itself might not be worth doing that. It might be easier to just create a few users directly in the IAM account and manage this like that, and it might be much quicker for you to do it. So think about it rather than complicate your life. Always remember, keep it simple, keep it easy, as I said before. So next one, identity information. Well, in here you can log, monitor, and track what users are doing with your resources. Remember when we mentioned this before, when you enable CloudTrail, which we discussed probably on lesson number 2, you'll be able to log every single activity from every single user that actually interacts with the whole account. And that's a big benefit for you. What it means, you will have full audit and history of everything that is happening. And how it works is AWS CloudTrail creates log files for every single account and uploads this to an S3 bucket specified. And then you can basically fetch those files from the S3 bucket and basically parse them or read them because they're in a clear text file, which means you will have a full visibility of what's going on and maybe what happened in case something broke. So you can trace back and see exactly what is wrong. So, sorry about that, let me just disable this. Now, also, we will be discussing a little bit more about PCI DSS compliance, what it is and why do we use it. Well, payment card industry, which is PCI, and data security standards compliant is used, for example, when you're taking credit card payments on the websites for online stores. It's very common, and you must be PCI compliant, and you must obtain certification to do that. And we will look a little bit more into this in the next few slides. Now, another benefit of using the IAM itself is that you have a multi-factor authentication. What it means is not only you have to provide the password itself, but also you need to provide a second method of authorization for the users in order for them to be able to access it. How it works is, well, you have a bunch of users, and all those users are using they want to use console. So they basically get a link to the IAM console itself, where they put their username and password as a standard, but also they provide a code from an MFA device. It can be either a physical one, like a little token, or it can be actually software installed on your phone, something like a Google Authenticator that generates password every, let's say, 60 seconds. And when user is logging, they must provide the most up-to-date code in order to authenticate in here. And it's a very common scenario that people can by default, lots of people actually enable this because it improves security of the account. Why? Because lots of people send their own username and passwords, maybe via the email, maybe they save this on their computer. Guess what? Their computer got hacked, or something actually went through all their files, the username and password leaked, and somebody is, for example, a full admin of your account. Guess what? This username and password can be used by hackers or anyone else out there to access the account, and you have no idea about it. But if you have an MFA device, then every 60 seconds, hacker actually must provide, when they want to log in, must provide this particular code, which is randomly generated and allocated to this particular user, which means it's next to impossible, even if you have username and the password, to actually access resources, which I would highly encourage you to do. I have another question here. While auditing, how much does that affect the performance? This is because in Oracle, Signal Trail is there, and if we enable, does it give any performance issues? No, it doesn't. Imagine that AWS CloudTrail is working in parallel on the AWS itself, and it doesn't slow down any of your systems. Everything is logged anyway by AWS behind the scene. It's just when it's disabled, you don't have access to this. When you enable this, it actually outputs the data into the bucket itself, so there is no performance degradation. So there you go. I have another question, Charanjit. Can we assume RSA token authentication also like MFA device? Yes, it's exactly the same. It's exactly the same principle. You can actually access on the AWS website the page about MFA authentication and what kind of levels are provided there, and you can see if your maybe MFA or RSA tokens are actually on the supported list, and if they are, you can actually use it. So there you go. That's what we would do. Another thing that IAM actually provides you is a password policy. Now, what it is and how do we use it? Guess what? By default, when you create an account, it's pretty okay. I wouldn't say it's strict, but it's okay. The minimum amount of characters allowed is 6, which is obviously better than random 4 or 5 that is allowed on many other systems by default. You can then enable different features like require at least one uppercase, require at least one letter, one number, and you can basically even enable something like enable password expiration, which is actually very good, and then you can put after how many days, and all of those little features that you have will enable you to secure your access to the AWS account in a much simpler and much more secure way. Why? Well, guess what? AWS itself is not a physical data center that you can just basically go in, like maybe your on-prem systems or servers, where they are guarded by, let's say, maybe CCTV, maybe you have obviously locked door, maybe you have maybe guards, or anything else you might have in the place. AWS itself is a basically cloud service which doesn't exist as a premise. You have no access there, which means all access you can have is only virtual, hence to the internet. So make sure you actually tighten all those policies and maybe align them with your company, which means that you don't use simple passwords like 1, 2, 3, 4, 5, or maybe password is password, so it cannot be broken and your account can be taken over by someone and be used for wrong, or they can spin up lots of resources and you will pay for this. So make sure you understand that and you also go through this by default. Now, we're going to describe a few IAM policies. An IAM policy is, and then we're going to say what it is. It's a document that defines one or more permissions. It's attached to a user, group, or role. It's written in JavaScript object notation, which is basically a JSON format. It's selected from predefined AWS list of policies, or you can create your own policy. Yeah. So basically, that's it. When you create a new policy, it's basically a simple, let's say, text file in the JSON format, and you can specify all the rules and permissions in there. It can be as simple as I only allow this particular user to access a single resource, or I allow user to access everything, and we'll be looking into this in a second. So, AWS itself has many, I would say, in fact, loads of predefined policies, which will allow you to define granular access to your AWS resources. In fact, when I started, I basically only used AWS predefined policies. It was more than I needed, and they were pretty much awesome. What you can think is in a filter window here, you can basically type anything you want, like S3, for example, or you can type maybe EC2 or RDS, and you will see all the policies that AWS thinks that you might use, and they predefine them by default. And they have lots of policies. They have, for example, policies as a full administrator access, which quite likely one or two people in your company should have in order to create other users. You might have Amazon S3 full access, which means a user will be able to access all the S3 buckets, read and write, but no other resources. You can have lots of other ones like APIs. You can have every single service will have its own permissions. Obviously, like administrator, for example, will have pretty much all access to all services, so make sure you understand that, but we'll actually talk about it. And as I said, there are over 200 predefined policies. In fact, the number is growing more and more because AWS is introducing more services, and every single service will have multiple policies. So it's more than 200 right now, but it's a huge number. I have a question from Challenger. Why AWS is using a JSON for writing policy documents? It's actually a very good question. Nobody really knows. I think the reason why they went with JSON is because they wanted to unify their systems, and pretty much everything else in AWS will use a JSON as a standard. So CloudFormation, for example, and pretty much anything else will use JSON. So that's pretty much what they went with. They thought it's clean, it's easy, which in some cases it might not, as you probably already know because you're asking this question. It might be confusing a little bit here and there, and it's a massive file as well. It's what they went and what they had, so I think we need to just adjust to that. I have another question here from Ravi Babu about MFA. So MFA means different users access the same AWS account, or how is it? Can you explore more on the same? MFA means that when user is logging into the account and they provide username and the password, on top of that, it will ask them for MFA code, which means that when you have a token in your hand or even application running on your phone, something like a Google Authenticator, for example, it will generate a code, random 6 digits, that you must basically enter while you're logging in. And that code is matched with your account, and if it matches, basically, which obviously it does because you just typed it, it allows you to log in. But this code changes every 60 seconds, which means if you didn't put your code within 60 seconds, the other code expires, which means nobody can use it. The old code, you need to specify the new one. This way, AWS knows that when you're logging in, it's you, it's not somebody else who took your identity, because they don't have MFA in their hand. So that's exactly what it is. So, skipping a little bit more, we're going to be discussing a little bit more about administrator and access policy. What it is administrator access policy provides full access to all AWS services and resources. And this is important. You need to remember that if you start granting administrator access to everyone, they will have full right to basically create new stuff and also delete every single existing resource that you ever created. They don't have any restriction, which is a little bit scary because if someone doesn't know how to use AWS and you granted them too much permissions, they can simply break the whole account. They don't have a right to terminate the whole account because that you can only do with the root account. But if you have production servers or any resources or even uploaded lots of files into S3 for backup purposes and someone actually went there and deleted it by mistake, well, guess what? It's not very pretty. And I can give you a very good case from a real life what happened. I worked for this company where admin didn't have any clue of what kind of permissions to assign, and he pretty much gave everyone a full admin account. And there was this one user, let's call him Bob, just because we can. And Bob was okay. He knew how to use AWS more or less, but Bob wanted to use an application that he downloaded from the internet. It was a free application to browse the S3, and it was free and it was okay. And the application itself asked him to provide credentials to access AWS S3 itself, and so he did. But the problem with the application was that application went a little bit wonky and crashed at some stage. And what happened is when he was browsing for a specific bucket, what he didn't know is the application actually crashed and started deleting all the files and sending this command to AWS. And because he had a full write on the whole account, he basically wiped out the whole content of a S3 bucket. And funny enough, that was a production bucket, and he caused lots of issues and damage to the company without even knowing about it. So it's not always about the user. Sometimes it's about the applications that you use. So make sure that when you give someone permissions, they don't have destructive permissions like a full admin to destroy everything else out there. So I have another question here. Should the new user be created using root account or the admin user? It's a very good question. Now, I would say like this. When you create a new account, you only have a root account. Basically, with a root account, create yourself an admin account that is actually tailored towards you. And on this moment onwards, never ever use root account. Obviously, I would advise to secure root account with the MFA, some sort of, so nobody can take those credentials, even if you saw them maybe copied in the file, maybe this file got leaked or something happened. So make sure you have MFA on the root account. And then from this moment onwards, use only your own full admin account to create other people. Why we will do that is because if, for example, we are logging activity with the CloudTrail, as we mentioned before, and everyone uses root, well, you cannot know who actually is accessing because everyone is called root, so you don't know who broke stuff or who accessed stuff. So I would say create dedicated user, and with the dedicated user, then create other users. So there you go. So basically, that's the little tip for you guys. Now, there is another one called Amazon EC2 Full Access Policy. What it will allow you is not only access EC2 itself, but also a few other services like Load Balancer, Amazon CloudWatch, and also auto-scaling. And pretty much all those services, if you think about it, they're kind of separate, but they're actually linked when you're thinking about it, because in order for you to have a full access to EC2, there are subsystems that are integrated and work in parallel together in order for this to work. So when you have Amazon EC2, well, sometimes you use also ELB, which is a part of EC2, but by default, a load balancer has its own permissions and policies. The same applies to CloudWatch, which obviously shows you all the statistics and performance charts, as well as auto-scaling, which allows you to spin up more instances automatically. So in Amazon EC2 full access policy, you will have access to all four by default, which is very handy sometimes. So I will skip a little bit forward. Another type of the policy itself, what we have is Amazon S3 read-only access. It's a very, very common policy that we use because it only allows read-only from a specific service called S3. Now, it's good because it doesn't allow access anywhere else. However, you need to remember that this user will have access to every single bucket on S3, which sometimes can be dangerous because if you think about it, if you have multiple buckets and some of those buckets might contain information like a secret to a company that may be sensitive to a market or maybe some stuff, your client's data that maybe shouldn't be accessed by anyone, if you grant someone S3 read-only access, that means they will have access to the same bucket but in read mode only. Yes, they cannot delete stuff, they cannot overwrite stuff because they have only read-only access, but they can still access this. So maybe it's important to remember to not do that when you're setting it up. So I have a question here. I see a question from Ravi Babu. What is the difference between admin user and the normal user in terms of roles? It's a good question. Admin user itself will have access to every single service and will have access. It's basically like a root without being able to terminate the account, which means you have access to everything. Read, write, change, modify, delete, anything you can think of. And the normal user, you will be able to allocate normal user with on specific rights to specific services. If you, for example, use this one as a S3 read-only, you will only be able to access a single S3 bucket in the read-only mode. So that's important to remember. So I have another question from Bhavish. It's, can we restrict the access to multiple S3? Do we need to create a new policy that this kind of access? Well, yes, we can. What you can do is you can create a single policy that on the bucket saying that the only access to this bucket is from that particular group or from this particular user, and every other user is restricted by default. And what happens is even if someone has read-only access, that means that if you locked it with your other permission, it means that the lock permission will be more important than access everything. And this way, you can restrict access to the bucket itself and only allow specific user or group of users or maybe systems to access that. Another question from Chandra is, by default, we will have only one S3 bucket. Actually, by default, you don't have any buckets created on the account. I think what happens is you need to create a S3 bucket by yourself, and we'll be going through this in a probably next session. S3 is there as well as RDS, so we will be able to discuss that. But by default, there are no buckets available to you. So that's another question from Chandra. Can we create multiple S3 buckets? Yes, we can. You can have as many buckets as you want, and they must be unique. The names of the buckets must be actually unique worldwide, which means if you're going to create a bucket something like maybe upload, or maybe my file, or my files, or my folder, quite likely someone already used it, which means that you cannot create it, so they might be unique. The good idea, if you think about it, is to give some sort of prefix to it, like a maybe name of your company, and dash a folder that maybe you think of, and that way you can be sure that nobody else is using that. I can see more questions about S3, and I would say I'm actually more than happy to answer all those questions about S3, but I would say let's wait up until we reach the S3 itself, and then we'll be discussing all the policies regarding the S3 itself. And quite likely we will have also a demo today that I will be able to show you a few things and tricks about it. So basically, what is JSON and how we use it? JSON is a very interesting file format that defines all the policies, and is using Java Open Object Notation, which is also known as the JSON itself. It's using policy-wide information, so version date, so when the policy was created, and it is also using multiple layers of basically order. So in this case, we have a version, and then in the statement, we open the bracket, and then we put what kind of statements we have. So we have effect, allow, action, S3 list buckets, and resource, and you specify which bucket you want someone to access. What happens here is we allowed access to list all the buckets, pretty much this bucket, and we allow, but specific this policy to only list what is inside example underscore bucket. And that's pretty much it. This single policy will allow a single user, if you obviously allocate this this policy to the user, to only list what is inside of this particular bucket, and that's it. It's simple, and it can do this. I have requests to repeat this. Absolutely fine. So the effect in this case is allow, which means that we are allowing access to specific resource. Action is S3, which specifies access to the S3, and then action on the S3 itself is the list bucket, which means basically we list a content of what is inside. Now, resource, which means what do you want access, is basically a bucket name, which is in this case we use example underscore bucket, and will allow to show to the user, so basically list all the content of this bucket itself. So I hope that's understandable. I have a question from Challenge. What is ARN? ARN is basically it's basically network extension that you need to specify, and it's a format that AWS basically requests you to do. It's basically like the address to AWS of what resource you need to use. So ARN is basically like address. AWS is a service. S3 is a component of the service, and then example bucket is the resource that we want to access. I see another question. What is the difference between a list bucket and example bucket? Well, okay, the difference is that a list bucket itself, in here, it's an action, which means what kind of action can be performed on that bucket. Think of it as in Windows, for example, you have a folder, and the folder you can allocate actions like you can read, you can write, and then you can read plus write, right? So action is basically what can happen. So read, write, and also lists, because you can restrict users from seeing what is inside. But resource itself is a name of the folder. So if this folder is called example, like let's say underscore bucket, that's exactly what it is. That's the folder that we want to access, and that is the permission that we want to grant. I have a question from Charanjit. What the 3 columns mean in here? Basically, that's a format that AWS itself requests from you in order for the resources to be specified. So basically, you're going to see pretty much every single time when you use any JSON policies that particular format, so on colon, AWS colon, and then resource, and then 3 dots, is used all the time. And that's the format that AWS allows you to specify when you're creating policies. Now, if you make a mistake in this, don't worry, because you have so-called a policy validator, which is a big button before you actually submit that, and that will allow you to validate if your policy is valid and you didn't make any mistakes. And trust me, with so many characters in here, you can. Sometimes you forget maybe about a single dot, maybe you forget to close the bracket, and when you validate that, it will basically show you straight away. From Charanjit, sometimes I see content between those 3 columns. Sometimes you will, because certain services will actually have intermediate resources in between. S3 is a simple service that is basically just the name of the bucket. There's nothing in between, and that's it. So S3 has only bucket name itself. That's why it's only 3 columns and nothing in between. We will see more with probably more examples here in the next slides. But let's move on, and hopefully we'll get to this soon as well. So what we're going to do is we're going to create an IAM policy, and we will demonstrate how to do this. What I will do now, I will basically go to my AWS lab, and feel free to do this in the same time if you want, or if you don't, you can just watch how we do this. In order to do that, we will go basically to services, and under services, under security, identity, and compliance, we will go to IAM. Once we are in the IAM, I have, funny enough, I have very restricted access in the policies. Get started, create a policy. Now, when we click a button, create a policy, what can happen is it will allow you to, sorry, 1 second. Yes. It will actually allow you to do a few things. You can copy an existing policy from what we've seen before that AWS specified. You can generate policy from the policy generator, which has pretty much every single policy out there, and you can also create your own, in which case quite likely you Google something and you just want to copy and paste it. What I will do is I will basically create an existing policy and just rename it for the sake of the exercise. Unfortunately, for some reason, my user doesn't have a right to do that, which is interesting enough. Let me do it a little bit differently in this case. What I will do, I will log into to a different account. So what we're going to do is we're going to go to IAM, and in the IAM, we will basically go to the policies. In the policies, we're going to create a new policy, and in here, we'll be able to copy an existing policy from AWS. Now, we can basically search. As I said before, there are quite a few, and the list is very, very long, over 200. And what will help you is basically to search in the filter. So what I'm interested is S3. What I want is maybe read-only access. And there you go. That's our basically policy. So just to describe this policy is as follows. What we have is basically policy version, which basically in AWS itself doesn't change. It's always the same number. And then we have a statement. In statement, we actually allow in actions to get star and list star, which means to get all the content and list all the content from the resource. And in this case, it's a star, which means that the users will be able to list of what is inside of the bucket itself, as well as download it to basically get it. And the resource star, in this case, means that users will be able to get access to pretty much everything on a whole account. So that's important. If you use a star in the resource, that means access to pretty much every other bucket. So what I want to do is I'm not going to change this policy, but what I will do is I will basically create my own policy. I will call it demo S3 read only. And the good idea is not to use spaces. And description, you can put whatever you want. I will just put some random stuff because it doesn't really matter to me, but it will be good to describe in the description, because if somebody else using this policy on your account, they will quickly be able to read it and understand why. So when we create this policy, you can see that in here it said the policy name must contain only alphanumeric characters and following, which means did I actually put a space? Yeah, I put a white space at the end, and probably that's why it didn't work. Now, before I actually create the policy, you can see here that we have a validate policy. This is exactly the policy validator that I mentioned before. So what happens is before I save it, I can validate it, and suddenly in here, in the green field, you can see the policy is valid. That means that it was just parsed, and it's exactly okay. It will work. So what I do now is I basically create a policy. And if I'm going to go to S3 in here, you can see that suddenly we have a new demo S3 read-only policy, and the one that we just created doesn't have any logo here, which means it's not an AWS policy itself. It's ours. And then with this policy, you can then attach it anywhere else you want. So there you go. This is how we create it, and this is how we do it. So I will switch back to the slides so we can actually go a little bit more and further. So what it is, users are defined as a people or systems that use AWS resources. And basically this is what we define as an IAM user. It can be as simple as a single person like an admin. It can be an end user that actually accesses the systems occasionally, or it can even be a system itself that is defined as a user that is granted permissions to access specific resources from AWS itself. And that's what it is. So, security credentials. AWS provides numerous ways to provide secure user access to your AWS resources. So, what it is and what happens. Email address and password. They are created when you sign up to use AWS. They are used to sign in to AWS web pages. And exactly this is what it is. Basically, you will specify email address and the password, and you can use those two in order to access the console itself. Let me just minimize this for 1 second so I can see exactly what we're talking here about. Now, IAM user name and the password. They allow multiple individuals or applications to access your AWS account. Individuals use their usernames and the passwords to sign in. So what it is it's not an email address that is assigned to a single person. It's basically a username that is not an email, and then you use the combination of the random user as well as password in order to provide multiple individuals, applications, or systems to basically authenticate against. And when would we use it? Is, well, you have a situation. You have, let's say, maybe 2 web servers that running in parallel, or maybe even 3 if you want, and they need access to, let's say, S3 because they need a specific file in order to function. Well, guess what? You'll create a single IAM user for that. You basically grant all those systems a single IAM user, and the user will be allocated with the same permission, access S3 itself. So all those 3 servers, maybe even you have hundreds of servers after that, will use the same permissions, and that's exactly what it is. What we also have is a multi-factor authentication, which is exactly MFA that we discussed. With that, you will be able, it's not enabled by default. This is what I need to stress. You need to enable that, and then users are prompted to use the username and the password, and in addition, they will need to use authentication code from the MFA device in order to be able to access AWS console resources. So this is what it is. Another type of security credentials is basically access key. And the access key itself consists of a key and the secret key. And that's a basically pair that you always use together. And that is used when you're trying to access programmatic requests, which means basically when you're using command line interface. So you're trying to maybe code in your application access to specific resources. You're trying to access maybe S3 or create maybe some servers because you can. And you'll use access keys because that's how you connect with the CLI itself. Another type is a key pair. Key pair basically is a public and private key that you can generate either via the AWS or you can have already existing ones in your environment. Now, key pairs are very, very popular in the Linux environments, and this is pretty much how most of the people authenticate to their systems. They don't tend to use username and the passwords. What they do is they create a single key pair on their own device, so maybe your own laptop or computer, and then you distribute the part of the key to the systems that you need to access, and with your master key, then you can access every other system because it matches your shared key that you actually distributed against the system. So this is exactly what it is, and it also allows you to access AWS if you want to. If you for example have already a keeper, you can use this to use on all AWS resources using this method. So this is what it is. And let's go a little bit further. Now we have a situation. If you were the AWS administrator of your company, which of the following options should you use to grant user access to the account? And then basically, imagine you have, let me just, sorry, stay with me just 1 second. Now, you would basically have situations like, sorry, I have one question here. Can I create a web server as AWS user? No, you can't. What you will need to do in this case, you will need to create a user that has permissions to access some resources, and this user you will be able to allocate to the server as, for example, a role, which we'll be discussing in the next few slides, and that will basically grant your web server access to AWS resources. So this is how it is. So basically, in this chart, we have a bunch of users that are exposed to AWS itself, and all those users can either use in situation A, a single user, or they can use IAM itself as a different users. Now, advantage of that and disadvantage is as follows. Yes, in this case, all you need to do is create a single user that you share between all the colleagues or within your company, and pretty much you know that whoever logs in with this user has always the same rights because it's a single user with a single right, which is great. But in this case, you create multiple users here, and that authenticate against the IAM policy itself. What happens here, you will need to create multiple users, in this case, let's say 3, and all those users will be logging to the console the same way. But what's the difference between those two? Well, guess what? If you have all the users, like in this situation here, connecting by a single user, you cannot really track who is doing what because everyone logs in as the same user, and in your even logs, everything seems to be the same. While in here, you can have a full view and audit of every single user accessing your systems. So it would be in your advantage to create multiple different users with multiple permissions because not everyone will be equal and the same in your company. So that's the advantage. It will be a little bit more work because you need to create a few more users, But trust me, long term, you're going to be thankful because if someone breaks something, you'll be able to know what happened and why. So that's the situation here. So we're going to be creating IAM user itself, and we're going to demonstrate how to do it. So I'm going to switch to my account. Basically, I know that the Simplilearn account is actually locked for that, so I will use my own. So just watch if you can. We're going to go to users itself, and I'm going to create a new user. Well, I'm going to create a user called demo user, and pretty much what I wanted to do. And in a AWS resource type, I want this user to be able to access maybe either a console, or maybe they want to have a programmatic access. Well, what it means, when I click the programmatic, it means that I want the user to be able to access AWS API, CLI, and SDK for maybe development tools, which means they will only have access via the command line. And it will generate the key for them and the secret. Well, this option here, AWS Management Console access, which means they will be able to use their username and the password, which can either be auto-generated here, or you can use a custom password, which obviously must match your policy itself, in order for them to access the console itself. Now, you can select both if you want. If someone wants to access the console and use the key as well for specific application, which is fully available. What I want to do in this case is I want maybe to create just the access to the console, and I'm going to auto-generate the password itself. So you can also see that once you auto-generate the password here, you have an option require password reset. It's ticked by default, which means that the password user once logged in using this auto-generated password will need to change the password itself. So what I will do is basically I will create it. You can see that now the second tab is set permissions for a demo user that we're just trying to access. Well, guess what? In this case, what we can do is maybe maybe we want to use, we can actually have a groups. We can have, you can copy permissions from existing user, as well as you can attach existing policies directly. Well, guess what? We just created a policy called demo S3 user here, but we can actually filter this. If you're going to put a demo, you can see the single policy we created with this description, which is not very descriptive, but we did. We can tick that, and we can go next. That's where we review it. So basically, everything is in order, and then we create a user. What happens now is the user was created, and you can actually see here that the demo user was created himself, and we have a password here, and we have an email login instructions. Well, it's a very, very good thing, and I would highly encourage you to show the password, because once you go away from here, from this page, while you create one, you cannot ever see the password. You can reset it, but you will not be able to see it. Also, I would advise you to maybe keep the, if you want to keep the password for the future use, what you can do is you can click on the button here called download.csv, and that will download an Excel format file with the username and the password itself. And you can keep this for your records, maybe on your own systems. So what I can do is I can maybe download this first of all. So I can download it, I can show this in a second, and I can show the password. So it was auto-generated, it's a bunch of random characters, as you can see. So I can also send email. It will ask me, you know, what system do I want to use. I have Outlook. It will basically put all the information in the email, and we can send it off. But we also generated the file, and I'm going to show you how it looks. You can see here that the user is called demo user. The password is this. It doesn't have a secret key and doesn't have a secret access key because we did not want the programmatic access. And you can see that the access to the console is via a specific link. And you can send the link to the user. You can send them username and the password, and they will be able to authenticate to your console as this particular user. And that's as simple as this. So we just created a whole user and assigned permissions. It's that simple. It probably is even more simple than creating AD, so Active Directory user, because it's basically next, next, next. And that's pretty much it. So it was as simple as this. So now we're going to go to IAM groups straight away. What is an IAM group? It's basically AWS defines a group as a collection of users that inherit the same set of permissions. It's basically the same as a group in AD. So you specify a group, you allocate multiple users to the group, and all of those users within the group will have the same permissions, because you can allocate permissions to the group itself. And it's very handy. Now, when we use it and why we use it? Well, if you have, in this case, maybe administrator access, and you have few admins in your company that must access the AWS itself. Well, yes, you can grant all of them admin rights individually as a user, but would be better to create a single group called admin group, and basically put all of the admins in there and allocate the admin group with the policy with administrator access. In this case, you only change this policy once, and you affect all the users. What it means is that if, for example, you want to update the policy, you need to update the policy for all those users in the company, and I mean, like, few is nice, but sometimes you have maybe 20, 50, sometimes even 100 users that you must update. And trust me, you don't want to sit all day long and click on all of them. Hence, you only change one thing in the group, and all of them will inherit the same thing. So that's very handy, and it's very recommended. So what we will do is, most of the time we will create different groups for different kind of people. We might have developers, and we might have admin, as I just described. And in the developers, we have users like Mike, Jane, and Anne. And in the admins, we have Mark, Sarah, and Jim. And guess what? In developers, we'll have access to slightly different resources. Admins will have access to pretty much everything. But that's good, because you don't want developers which have no knowledge of AWS itself to go log in and start breaking stuff because they don't understand how AWS works. And this is how you would exactly do this. So it would always be recommended to create a different groups or different kind of users and try to allocate them across the whole company in each group. The good news is that one user can be a member of multiple groups. What it means, if for example you have a user called admin and you granted him permission to admins and you granted him permissions to developers, well, guess what? Admins have rights to pretty much everything, and developers have restricted access, which means they're kind of overlap a little bit. They have pretty much the same rules, with the exception the developer is a little bit restricted. What it means, it will still have a full admin rights no matter what, even if it's part of the developers. That's as simple as this. So it's actually very good. So yeah, there you go. This is how we do this. So creating IAM group. So I will show you how to do it right now. I will go back to the IAM. I will go to the groups, and I will go to create a new group. I will call a demo group, and I will click next. And basically, it asks me to attach the policy. Now, I can, but I don't have to. In this case, I will, just because I can show you how it works. I can basically filter this through. Sorry, I made a demo, and you can see the policy that we generated. You can just tick and add and create, and that's it. We just created a demo group with the same permissions as our user. And that was as simple as maybe 3 clicks, and it took me 10 seconds to do. In fact, you can do it maybe in 5 if you really click quick. So there you go. This is how simple it is. So, IAM roles. What are IAM roles? Well, it is very similar to a user itself. AWS identities with permission policies that determine the access available to identities, and I'll actually explain this in a few seconds. Not password protected and do not require access key, which you can, if you think it's, wait a minute, that's actually unsecure. There's no password and there's not really a protection and it doesn't require keys. So why would I want to use it? And also assumed by anyone who requires them. I'll go straight into this and explain how it works. So basically, imagine you have let's go through this like this. Roles are used to provide access to users, applications, and services that do not have permissions to use AWS resources. Well, if you think about that, what does it mean? You have maybe an application in here, and this application itself requires access to S3 bucket to get, in fact, a photo. So application requires access to the bucket itself. But guess what? You don't want to grant this particular server generate the whole access with the keys, with permissions, and everything else, just like that, because maybe your application doesn't support it. You cannot just program this in your application. You just want it to be able to use it. So what will happen is you will be able to create a role that grants access to the photo bucket. And the role itself will basically launch the instance itself and assign this particular role. That's important. When you're launching the instance, you'll be able to assign that particular role to the instance itself. And what happens is this application, once fully running, has access automatically to the bucket itself without providing any credentials. If you think about it, it can be tricky and scary sometimes, because you think, why would it happen? Well, guess what? Applications sometimes must access specific resources on AWS, and you don't want to authenticate every single time that this application accesses this. It's as simple as, if you have a server somewhere in the office and this server requires access to your file system at the end, you can actually whitelist the server saying, I need this server to be able to access it because maybe it's a backup server or something. And it will not require a username, it will not require a password, it will just allow access, but only to this one machine. And this is exactly what we have. So you don't need to make your application complex to pass any keys, any credentials, because maybe someone will hack, or maybe someone will just log into your server, and they can actually see all those keys, and they can use this key for themselves somewhere else to access the same resources. A role itself will only allow one server that you spun up access to a specific resource, and that's the beauty of that. I can see a question here. This means the policy is created and granted a group, and to a group is granted to users or roles with the same permission, correct? Or if I'm wrong? I don't really understand the question. Policy is created. Okay, I understand now. So basically, what Bhavish is asking is, the policy itself, when we create, is basically a file that allows you to specify permissions itself. So what kind of access we have. And then we can grant this policy to a group, and we can assign any number of users to the group itself, which means any user underneath the group itself will have exactly the same policy as the group was assigned with. So this is how exactly it works. I have another question here. In this case, are we creating a role to access the S3 bucket alone? Yes, in this particular case, yes, we can. In fact, we can create basically a role which has a permission to access specific bucket, or maybe even specific folder under the bucket, and we can say this particular application has access to this folder and can access any, let's say, star JPEG file, which means it will be able to access this without requesting credentials and exchanging any security information. It is still secure because it's only assigned to a specific box, but that's it. It's actually very good. So basically, Chandra is asking, can we treat IAM role as a RBAC, which is a role-based access control policy? Yes, we can. It's pretty much the same. If you think about it, it's just a little bit simplified, but it works in the same way. So yes, we can. Can the same thing be done by assigning policy? Yes, it can. But if you will do that, so if you, for example, you will, in this particular case, you will not use a role, but you will use IAM user. In this case, you will need to program within your application a username and the password, or access keys, so basically a long access, which is basically a key, and then a secret, which is a bunch of other things, and you will need to use API or any other means to access your resources, and you will need to authenticate every single time. And not always that's the best and the quickest way, because authentication itself is a little bit overhead. So if your application requests hundreds of thousands of files every minute or so, and you need to authenticate on top of that, well, it will generate a huge overhead rather than just grant permissions straight away, which can be actually, it's a simplification for your application, so you need to worry about authenticating yourself with a bunch of keys that can change or anything else. You're basically just granting permissions straight away. And what's important, basically when you're granting a role, and I think we have this in the next few slides. No, we don't, but I will tell you this anyway. When we're granting a role, what happens is a temporary access is granted for up to 1 hour, and every hour, access between those two is actually refreshed. So they do use a bunch of hidden keys behind it, but those are automatically rotated keys behind the scene, and it's not with your application, it's on the AWS level itself. So AWS takes care of the whole security and rotates every single hour a key behind the scene to make sure that you have constant permission. And that's all it is. To you and your application is simplification and its ease of use, but it's still extremely secure. So I would say majority of the time when we create applications, we always use roles rather than users, because it's actually much better. You don't have a bunch of keys that people send around in the emails, maybe copy and paste in the file, or keep it, maybe even paste it on like internet somewhere sometimes, and you can find those keys everywhere and you can use them to access people's files. You don't. It's actually secure because you don't have a key itself. So that's how it works. So I'm going to show you how to create a role right now on the AWS itself. So we're going to go to roles. We have no roles at the moment. I will create one. I will call it a demo role. I think you get a pattern of what we call things and how. And then you basically have permissions. Well, do you want this role to have AWS service access to the roles? You want this to have a role to cross account access, which means you can have an access from one role to a totally different AWS account, which you can basically access that different resources. Or you can have a role for identity providers, which you can actually have logging through Amazon, Facebook, and everything we said before. For this exercise, we're going to create basically a simple EC2. And we're going to go for our favorite demo S3 read-only that we created before. And create. And that's all it is. Suddenly, we have a role called demo role. And this particular demo role will have exactly the same policy as our user, demo S3 read-only. We can see the policy here, which is exactly what we have created before. You can attach new policy if you want to it, and you'll be able suddenly to attach this role to a server that you just created, and this server will have exactly the permissions that are specified in here, which means list all the resources to S3 without using a single username and password. And that's great because you can jump on the server and you can straight away start using it all to access all the resources that we just mentioned. I have a few more questions here. Can we assign multiple roles to one EC2 instance? It's actually a good question. I would say no. You can assign only a single role to a server, but you can assign multiple policies to each of them. And once the server is up and running, you cannot actually change the role. You will need to create a new one. So that's important to remember. Can you show me in a demo that will help us to understand more? Can you show me the demo that will help me understand more? I don't understand the question, Chandra. Can you actually elaborate a little bit more about that? I would really appreciate, and I'll be able to answer this question. I have another one. Oh, I have already shown you this. Okay, sorry. I hope I answered this by the demo itself. Who sets the memory load of the requests for the web server? I don't understand the question, Ravi Babu. Could you elaborate a little bit more about that? I'll be able to answer, obviously, more than happy to. Until then, I will answer a few other questions. What is the difference between a role and the policy? Well, the policy itself, remember, is a collection of permissions that we have and granting to specific resource. A role itself is basically it's a collection of policies that we can attach to any instance. So in this case, we created a policy called demo S3 read-only, and then attach this policy to a role called demo role, and that role we can attach to, let's say, a server, which means you can attach any number of policies underneath here and attach to a role and use it as to access multiple resources. So this is how it is. So basically, what we'll be discussing right now in the slide 53 is how to create an individual IAM users. What are the benefits of creating individual users? As I kind of mentioned before, it will generate unique credentials for everyone. You will have control of permissions on the individual level. It's easier to rotate the credentials in this way. You don't have any shared accounts, and it's easier to identify security breaches. So that's the benefit. And let's go straight into a next slide. You can also, when you have a single a user, as we mentioned before, and individual users, you'll be able, when creating IAM policies, you can grant a least privilege. That means that users, they can only grant requested, you can only grant them requested permissions, which means they have access nobody else, nowhere, no more than they need to. It's more secure to start with minimum permissions and then grow over time. So if, for example, I need only access to S3 bucket because I need to access data there, well, there is no point of you granting me permissions to everything because it's pretty much unsecure, which means that if I have requests in the future, hey, I actually need access to S3 and now I need access to maybe EC2, you can just add me access to the EC2 at later stage, and this is how it should be done. Least amount of privileges, it's always the best way forward. It's easier to grant permissions that revoke them. That's correct. It's actually much easier to grant a smaller permissions than start blocking. So when you grant permissions to pretty much to someone to everything, and then you're trying to revoke this, the document will look huge to try to restrict everything. It's easier to just grant one or two things and then build upon them. And one of the last things in here, let me just minimize this, is you can protect your assets, and that's very important. What it means is because you granted permissions which are minimum, hopefully, to a user, and this particular user doesn't have access anywhere else with the exception of what you granted them with, that means that because they don't have permission somewhere else, it's quite likely that it's protected because they have no access and they cannot read, they cannot delete, they cannot do lots of things, which is a benefit to you, and that's exactly what we're trying to achieve. So there you go. Grant always least amount of privileges possible. Now, manage permissions with groups. AWS always encourages you to use permissions with the groups to minimize the workload. What it means, it is easy to assign new permissions. It's easier to assign new permissions to a group than assign to many individual users. As I said, if you have a single account as a group, for example, and then you have a 50, 100, 200 users that want to use AWS, guess what? If you have a change in your policy and you granted individual permissions to everyone, well, and you need to kind of change this, well, good luck. You have to do it 100 times. It's easier to basically change this on the single group that all those users are members rather than do it on the individual level. It is always better. And trust me, after a while, you will have a mess. And every single user will have a totally different permissions, and you cannot control this because you will have other people that will have access there, and they will be changing stuff. So it's actually good. And the same, obviously, not only new permissions, but also reassigned permissions that are currently existing, which is exactly the same principle. Now, you can also restrict access with further conditions. Use additional conditions such as MFA and security groups to ensure only the intended users can get access. Well, that's exactly it. What you can also specify is the basically conditions under the policy itself that you can say, well, I want my users to have access, but I want them to use MFA, for example, or they're coming from specific IPs, like even this. And if they are coming from these IPs, they can access the production systems, because sometimes the production systems are very important, and obviously they should be they shouldn't really be accessed by everyone in your company, only by the trusted people and the ones that should have access there. And the rule is simple: less people have access to something, less likely is it that it's going to break. And that's the point. So you can actually add additional conditions like, I only want users with maybe this IP address, or maybe this IP address, or maybe this IP address to be able to access my production server. And you can have this by using conditions. And I'm going to show you how to use it as well in the few minutes. Monitor activity of your AWS account. As we said before, and quite likely we're going to mention this multiple times in the future because it's really, really important, is that AWS has several features to log user actions via logs or via the cloud tray itself. And all of those for every single users are being logged into a single S3 bucket that you can actually access and browse through and see exactly everything, what is going on with your account and which user is actually doing some activity. So there you go. I have a question here from Ravi Babu. If web server is not able to handle requests, if it crosses limit, it has to route to another server, so which user has permissions to route the request to another server? I would say, interesting concept. For example, in this case, if it's, let's say, a web application, I presume, then you don't really need any permissions itself, because you can access the web servers on the, let's say, port 80 or 443, doesn't really matter, without any permissions itself. All you need to do is open security group in between all the web servers within a pool to be able to be accessed on port 80 or 443. And in this case, it's going to be like from the internet. The web service itself will have access to any server on any of those ports. Now, this is something we usually don't do, because obviously we're trying to restrict cross connectivity between the servers in case one of them is actually kidnapped by hackers or something actually happens, and they can spread between all other servers. So you kind of try to mitigate this by not allowing anything but only ELB to access, let's say, on the port 80 itself. But it's doable. So you wouldn't really use permissions, because you can use just port 80 and that's it. So I hope I answered your question here. Now, as we said before, you have also a right to create a strong password policy itself, and you can actually have few things. You can specify a minimum amount of characters in your password, which is always a good thing. You can require at least one non-alphanumeric character. As well, you can enable password expiration. And I would highly encourage you to tick as many as those boxes as possible. In fact, you know what? Go crazy and go for everything. There is not such a thing as too little security nowadays. And I've seen so many times people using such a silly passwords that it can be pretty much found on the top 100 password list available on the internet itself. And it's not very secure, because suddenly you're granting a user ability to have a simple password that anyone can log in with and have access to your entire fleet of servers, and that's scary. Normally you wouldn't do this. So there you go. You have such an option, so you can have that. Also, use roles for applications that run on EC2, and that's what we said before. Instead of granting users and having keys saved on all those servers and passwords and all the stuff, which is not very secure, as we know already, you can use roles that will be pretty much the same, with exception of no user and password required, and that's it. Application will still have access exactly where we want. In this case, the application will have access to the S3 bucket, but it doesn't require username and password, and that's exactly it. So, what's important, and probably I don't need to say this on AWS, but AWS and obviously wants you to know that, is that reduce and remove unnecessary credentials. What it means, if you have a user that is not working with you anymore, so maybe Bob left the company, guess what? Remove Bob from your access list. You don't want Bob to be still able to access all your resources while he's not working there. And that's obviously something common and obvious, but funny enough, lots of people don't. I've seen companies, pretty much every single company I've seen has a list of users that go like 3, 4, maybe even 5 years back, and there are hundreds of people on the list that do not work there anymore. And what's scary is those accounts are active. And even something more scarier is that some of those accounts are full admins, which means if the user that doesn't work anymore has still full access to the production environments, well, it's just a recipe for disaster. And make sure that if someone leaves the company, you always remove the user, as well as maybe once every month or 3 months, you do a cleanup. You go through a list of all the users and make sure that those users are working there. And if they don't, well, remove. And obviously, that's something that we would highly encourage. I can see the question here. Can we make user inactive? Kind of, yes, and I'll show you how. If I can, let me just remove this. Close this users. Well, I have a demo user here, and basically what I can do is I can go to this user, and you can see that this user has basically a simple permission. But also, you can see that the console, sorry, I'm going to highlight this with this, in console password is enabled, and pretty much that's it. There's not such a thing as enable, disable account, because there is not, but what you can do is basically, you can disable console access, which means I will just basically edit this and disable. At this stage, the user still exists, but they have no access to the console itself. But there is a different case. If, for example, we generated sets of keys for the user, which I just did, just to show you how it works, this pair is also available and it's live. well, guess what? The user it's not working there anymore. So what I will do is I will go to the console password. I will maybe disable it as a first step instead of maybe deleting everything. And also, just because I disable that doesn't mean that the user still doesn't have access. They do via the key itself, because the key is the access to the command line, despite the fact I just disabled the console. Console is just a web interface that we're logging in, but the real thing is the key. So what I will do is I will make it inactive. What happens is the key still exists, but it is inactive. And why I did that? Well, it's a very, very common situation. You have a bunch of users working in your environment. They generate themselves keys, and they use those keys for different things. And so, guess what? Sometimes they use their own keys to inject in some sort of applications within your organization. They didn't tell anyone. They just wanted to make sure it runs and works, and they didn't. And what happens is the whole application, even sometimes in production, runs off a user key. And guess what? This user might be a full admin, which means the application that is running this key has a full admin right to entire stack of everything you actually have, which is very bad. And I've seen this every single time, and it's really, really wrong. And what happens is you just delete, instead of deleting the account, you basically just make the key inactive. And what happens? Straight away, something stopped working. A system is not responsive. Something failed. You have alerts coming in, and instead of deleting the key, because once the key is deleted, you cannot recover it, which means it's better to disable the key, maybe wait for a week, 2 or 3, or maybe even a month, and in this case you can be sure that nobody will be able to use this account. But if you have a report straight away saying, hey, actually our AV system stopped working, and that user was, he created that, can you make sure it's actually fixed? You can be like, oh, okay, I disabled the key, so maybe I should enable the key, and better yet, I will enable the key for the system to work, but I will also, instead of using this demo user, I will create a special key for this application on its own, or even use role, in order for the application to work. And I will just give it a new key name rather than reuse the user that is not working with us anymore. And that's the very, very common way and very common issue where we've seen so many times. I see a question here: when a user console password is disabled, can they SSH into AWS? Well, yes, they can. Now, if you think about it, it works like this, and let me draw it for you a little bit. So basically, there are 3 types of access. One is the console itself, and the console is using the console password. So you need to use a username and the password to be able to access the console itself, and that's one way of doing that. Another one is API. An API is using a key itself and the secret key in order to work to access all the resources of AWS. And those 2 methods are responsible for accessing all the controls of AWS. Now, if you have an EC2 server, and this server is maybe a Linux box, it will have a keeper, right? Well, guess what? This particular keeper is actually sitting on top of OS, which means none of that, what we just disabled, is disabling the OS itself. As long as a user that is, for example, left the company, has the keys, you can even restrict all of this away from them. They will still have access to this box, because it's like basic username and password for the box that sits in the middle of the internet. So you need to make sure that you also rotate the keys of the servers if you gave someone those keys, and you clean those up. And there are multiple different ways of doing that. And I've seen every single company does this differently because they have their own policies. One of the best ways probably to do it is via the AD itself, which means the EC2 box that is, for example, running the Windows can authenticate against the AD server. And if you remove this particular user from AD, guess what? All the access to all the servers will be revoked straight away, because the user doesn't exist, cannot authenticate. With a single pretty much click in AD, you just remove the user from everywhere. And that's easy, especially when you have a fleet of servers of like 500, maybe 1,000, or even big ones like 50,000 servers. Guess what? Do you want to go through all 50,000 servers and remove all the user credentials? I don't, and I'm pretty sure you don't either. So there you go. Baggage is saying that one way would be to regenerate the key. Sure, it would. You could do that this way. You could do, you can do this via the maybe a command that you want to rotate the key on every single server that matches a specific query. You might want to have a command via the PowerShell that you want to remove the user from there. There are different ways, and there are different, you can do it in different ways. It's entirely up to you and how you worked with before. Now, what we will do is we will try to go through the entire EC2 slideshow in the remaining 2 hours. I would say, if it's okay with you, I would like to maybe extend today's session by maybe around half an hour, because it's important for both me and you to go through as much as we can through during today's session on the EC2, because it's a very important component of AWS. So by the time we're going to be reaching end of the session, I will basically say this again if everybody's okay with it. Hopefully we can squeeze as much as we can, and we can do as much progress today. So let's dig in straight into Elastic Compute Cloud, also known as EC2. What we will learn is overview of EC2. We'll also learn of what placement groups are, what Amazon Machine Image is, also known as AMI, what Elastic Load Balancing and auto-scaling is, instance types available for you to use today, Lambda and Elastic Beanstalk, EBS and EFS. We'll know about AWS command line interface, EBS snapshots, AWS recommended best practices for EC2, instance pricing options, as well as costs associated with the EC2 itself. So I'll jump straight into it. So that's an overview. Basically, Amazon Elastic Compute, also known as EC2, and quite likely you will see EC2 more often than Amazon Elastic Compute Cloud. It's a web service that provides resizable compute capacity in the cloud. That's as simple as this. Think of it as a server, or as a VM, or as any other resource that you can basically put OS, either Windows or Linux, and you can basically compute some applications, or you can compute something on it. And that's it. That's as simple as that. So, Elastic Web Scale Computing. It allows you to increase or decrease your capacity in minutes, which is exactly what we want. We want to be able to make boxes bigger, with more RAM, with more CPU, maybe more storage, and we can. Also, we can decrease it. So if it's too big and we want to make it smaller because we want to save money, we can, and that's done within a matter of less than a minute. We can launch thousands of servers in the same time, which means that if you have requests, for example, to suddenly be able to handle a huge sale on your online website, and you know you're going to have 10 times more traffic than usual, guess what? You don't need to provision weeks ahead more hardware, try to deploy this. You can actually, hour, maybe 2 before, you can spin up more servers to be able to handle more traffic, and once the sale is over, you can basically decommission them and come back to the original state. It's flexible because you can actually launch different OS systems on it. You can have instance types, and you can have different software just in minutes, and you can have any combination of all of them, no matter what. It allows you to integrate with other AWS products such as S3, databases RDS, SQS, which is the queuing system, as well as to provide complete IT architecture solution. So it fully integrates with everything else AWS has to offer. It is reliable and secure because AWS operates in an SLI commitment of 99.95% of availability. What it means, it's pretty high. That means that 99.95% of the time, they guarantee that the single box will be up and running. If you want those numbers to be even higher, you can actually deploy this between multiple regions and multiple even AZs. And in this case, the whole system is almost as 99.999 and a few kind of nines after that. Also, Amazon provides you with the VPC that you can create and secure whole networks for all your AWS EC2 instances within. That's what we were talking about during the VPC itself. And also, it's a low cost. AWS charges you by the hour, and you only pay for what you use. Rates are lower than your existing on-premise infrastructure. That's entirely true, but you need to be careful, because if you're trying to run all those servers with the same size that you would have on-premise, and compared to the maybe on-premise costs quite likely the bill might be a little bit bigger than you expect. So you need to be smart about it, and you're going to be discussing how to use it and when to use it to make it cheaper. Now, we're going to be talking about Amazon Machine Images, which is also known as AMI. So, what it is. Amazon defines AMI as an Amazon Machine Image, also known as AMI, provides the information required to launch an instance. You specify an AMI when you launch an instance, and you can launch as many instances from the AMI as you need. You can also launch instances from as many different AMIs as you need. So basically what it is, it's a copy of your server. And once you took a copy of your server, then you can basically create as many instances from this copy as you need. You can have one, you can have two, you can have a million. It doesn't really matter. And every single of those servers will be exactly the same. The same data, the same specification, everything will be exactly the same, which actually speeds up the deployment process. If you think about it, you can create a single server in the production environment and copy the server across every single other environment like development, staging, QA, and in this case you are sure that everything everywhere is exactly the same. So that's a huge advantage. So as we said, AMI is a virtual instance, and that includes a template for the root volume for the instance. It consists of launch permissions to control AMI launch instances, as well as a block device mapping to the specific volume to attach to the instance. What it means? Well, AMI is basically a sorry, let me go back. Basically, it consists the root drive that you have OS installed. It consists all of the permissions that are required to launch that, as well as any additional drives that you had specified if you need it. And that's exactly what it is. It's basically a copy of every single resource that a single server had attached. I have a question here straight away. Can we create an image from our data center and use that to create AMI to replicate the configuration in AWS? The answer is yes. Yes, we can. What you can do, in a simple terms, you can basically take, if I presume in your data center you might be running something like a VMware, and if you do, you can basically create open a format virtual file. So it's an OVF or OVA, depending on the VMware you're running, and that particular file you can upload to a AWS. It's a service called import export, and basically you digest it, and what AWS does, it takes this image and injects its own drivers into it, and then it creates AMI out of this, which means you can then basically launch a server from a server image that created on-prem, and that will be quite likely the quickest way of migrating your workloads to AWS, because you can actually have this running. They now also offer a new service called server migration service that allows you to basically integrate a connector directly with your VMware, and you can basically just tick the servers, and with one button it will allow you to create copies of entire VM environments on the AWS as AMIs, and it's up to you if you want to launch them or no. So it's a fully automated process now, since basically 2 weeks ago. So yes, you can. Now, I have another question from Challenging this time. Does AMI only support image from VMware? No, the answer is no. What actually supports is, as long as anything can export to OVA or OVF, it will be able to digest that. And there are a bunch of converters out there that you can use to convert different machines. The biggest challenge, quite likely at the moment even still, is to convert physical machines, so basically running on a full hardware without any VM on it, into the cloud. You will need to use some sort of third-party tools, and AWS is not doing that as yet, to be able to convert the physical machine to the virtual one, and then you take virtual and put it on the AWS itself. So that's pretty much the journey. So I want to mention now and say what is a root device storage. Before I answer more questions on that, I would like to just go through the slide. Okay. Basically, there are two types of root device storage for AMIs. One is called Instant Store, and the other one is called EBS. What the Instant Store is, it's basically a hidden place on S3 where you basically store all your AMIs. If you're going to go to S3 directly, you cannot see it. It's invisible to the user. It's allocated to your account, but it's only available through an AMI console. Otherwise, you cannot see it. And what other type is basically Amazon Elastic Block Storage, which is basically a network drive. So if you had a server, let's say in here, that was created, the server itself had an OS, which quite likely sits on the S3 as a part of the root device, and any additional drive that was attached to this particular server sits on EBS as a snapshot. And that's simple as this. So every single AMI sits on both S3 and EBS, depending how many drives you have attached. That's basically how it works. I see here a question from Havish. Okay, that's great. How about a Windows or Linux server which has the DB or web application installed? Can prepare an image to do that? Yes, you can. I would say there are advantages or disadvantages of doing lift and shift. So basically taking whatever is on-prem and migrating this onto the cloud. It's basically a pretty slow process, can be, but also it's not a clean process. What I would advise as a good gesture of advice from the experience is that most of the time when you want to migrate stuff to the cloud, it's sometimes quicker and easier to basically deploy from the scratch. So basically launch the server and just install application, then start and try to migrate lots of things from your on-prem. The reason is if you have old systems, and I've seen this quite a few times, they do not integrate well sometimes with the cloud because they were not designed for the cloud. And in this case, it's easy to create a new system, install everything on new, and have it clean rather than migrate. In some cases, it's impossible because the systems that you have and people that work on those do not work anymore. Hence, you have no expertise how to redo it again. In which case, lift and shift might be the only way you can do. So you need to convert those into the VMware OVA files and then ingest that directly into the AWS and try to launch that. So not always it will be 100% working. Sometimes Windows or Linux is running on the old core or old version, and it throws some sort of errors. I've seen this in the past quite a few times. Recently, I see it less and less because most of the modern systems are kind of cloud aware, so it's not a problem. But with the very old systems, sometimes I still see it. So there you go. I see lots of questions here, which is good. How AMI instance will identify EBS storage? Does it have any connectivity framework to identify EBS storage itself? Yes, AMI itself is basically a copy of an instance itself, and it has a reference to EBS from the snapshot. So when you create a new server, let's say you want to create a new box from AMI, what it will do, it will basically pull all the data from instance on S3, as well as take a snapshot, take this from the snapshot and restore as a drive. So suddenly you will have a server with a root device and EBS in exactly the same fashion. So AMI is basically a configuration file with the image on S3 and snapshot on the EBS. That's all it is. I will be able to answer more questions at the end because we're going to get stuck on the slide 13. We will never finish this session. So I know you have lots of questions, and I'm more than happy to answer, but if we have enough time at the end, so I do apologize if I cannot answer all of them. Now, instance store. Root device for the instance is an instance store volume created from a template stored in S3, as I mentioned before. So basically, instance store is exactly the place on the S3 that you store all those images, and this is where you store your data from the root device, and that's it. As simple as that. Now, Amazon EBS. The root device for the instance is also an Amazon EBS volume created from EBS snapshot. It can, and how it works is, for example, if you had your AMI, so let's imagine a situation. You had your server that a root device was actually a EBS volume, so it was EBS, which means when you snapshot it, the EBS volume itself had a snapshot created on the EBS itself, and now when you restore it, it is a root volume, which means it was not necessarily stored on the S3, but it was stored on the EBS as a snapshot itself. So you have a different scenario here, and that's pretty much it. So it's self-really-explanatory. Okay, I can see a question here of what's the difference between instance store and EBS. Okay, what is the difference is all types of servers running in AWS had instances running on so-called a root device that was not a EBS. What EBS is basically a network drive. So imagine that you have a server, and this particular server can run from two different devices. One is called ephemeral, and other one is called EBS. So let me just EBS, and this is ephemeral. So just to explain what ephemeral drive is the drive that is attached physically to the underlying host, so to the server itself. And what happens is if you have an EC2 instance and you shut it down, what happens in this case is you lose all the storage assigned to this. So basically you lose instance. Once the server is off, you just lost it. All the data that was persistent on it. The reason AWS did that is this was one of the first infrastructure attempts, and that was very popular around 7 years ago. And for around 5 years or 6 years now, EBS is taking over. In fact, 99.99% of servers running right now are EBS only, which means even if the server dies, the EBS is still persistent, which means all the data is still there, which means you can stop the server, start the server, you can basically create copies of it, and that's it. So the difference between your question now is that the old-fashioned ephemeral store was actually stored on S3. Now EBS itself is stored on the EBS volume as a snapshot, and that's the difference. So I hope I answered your question. And exactly here, we're quite likely going to see some differences in this particular chart. So we have Amazon EBS backed volume and also Amazon Instance Stored backed. So how it works is, the difference is boot time itself is usually less than 1 minute. And if you ever launching this through a store backed, it's usually less than 5 minutes. So it's much, much slower. Why? Well, because the S3 will be slower to restore all this data because there is a bottleneck of a single connectivity, while EBS is basically restoring a snap, which is much quicker. Size limit, EBS can be 16 terabytes, and instance store back can be 10 gigabytes. So you can see the advantage of EBS there again. A root device, a volume, it can be Amazon EBS volume, and in this case, it's called instance source volume. So it's different names and different capacity. Also, the most important thing that I'm going to mention at the bottom, and then I'm going to go through other few things, is that it can be placed in the stop state when the instance is not running, but the volume, root volume, is persistent in EBS. Now, the difference between EBS and non-EBS is cannot be stopped in the stop state. Instances are running or terminated. As I said, if you stop an instance with the Amazon Instance Store backup, which means you lose all the data, and quite likely you don't want to do that. The good news is 99.99% of the servers right now are running on the EBS. In fact, every single time you're trying to spin up a new server via AMI or anything else, its default function or default option is an EBS. You can still spin up old type instances if you really want to, but nobody does that. So the news is, if you spin up the server, it's almost 100% it's an EBS, so you have no problem with that. So basically, that's it. That's the explanation between those two. So another type we have is the HVM versus PV. What it is and why do we care? Now, PV stands for paravirtualize, and HVM stands for hardware virtual machine. What it is, it's an Amazon way of basically creating AMI images and keeping this in their own environment, in a virtualization environment. What it is PV was the old generation of virtualization that was dependent more on the software. So software was assigning lots of resources, was basically software-driven, allocating CPU processes and all this stuff. And it was, I wouldn't say it was slow, but it was a little bit dependent on software, hence there was a bottleneck. And then AWS came up with the HVM, which is a hardware virtual machine, which means the type of the machine that has access directly to the hardware it's actually running. Which, if you think about it, if you can skip all the software on top of that, and you have access to all the hardware that you really should, it's much, much quicker. And in reality, it is much quicker. And the difference is, in here, when you're launching sometimes servers in the brackets, you will have either PV or HVM. Again, 99% of the time, you're going to have a HVM because that's a default behavior now, because AWS wants to give you the most up-to-date and the quickest performance ever. Hence, you have this. So most of the time, you will see HVM out of the box. So, as I was saying, all the EBS volumes are stored under the EC2 dashboard in the Elastic Block Store, basically section of the page. And in order to access this, you basically go to the volumes, and you can see here that you can create a volume. And what it is basically a network drive that you can attach and provision. So if you create one, you can basically provision a bunch of stuff. I will show you this a little bit later during today's session because we will be talking about that. So yes, it's here, and we'll be discussing this. So coming back to the slide. I'm sorry, it was this one. So choose AMI, and the first step of launching any new instance is selecting AMI. So before you even start, you will need to create some sort of first server. And to do that, obviously you cannot put any CDs or floppy disks or anything else to basically install your OS. You need to have something already running in order to access that. And I would highly encourage you to use AWS Amazon Linux in the Linux section, because it's probably one of the best and cleanest builds I have ever seen. It's also probably one of the most secure, because AWS takes security really, really seriously and allows you to have extremely clean and yet secured build of a Linux itself. But also, they allow you to spin up Windows boxes. Obviously, in this case, we have a Windows Server 2012, but they also released recently 2016 that you can access. And pretty much that's it. You can see as well, I'm going to show you here, that they do specify that it's a HVM that we just discussed, which means that it's a hardware machine, which means it's extremely quick, as well as they specify SSD volume type, which means it's an EBS backed machine. You see there are no machines in here that specify the internal root volumes, because it's not really used anymore, because having server that is off and losing all the data is not really called server. It would be called a suicide in my case. So there you go, I showed you that. Let's skip straight into Amazon Linux is also supported and maintain Linux image provided by AWS, as I mentioned this before, and I would highly encourage you to use this, because it's a very good starting point, and AWS is taking full responsibility to update this very, very often. You can see basically new builds of the same updated box every week or two, and they release new AMI, and every single time there is some sort of security threat or some sort of announcement, they always patch those boxes straight away, which means if you launch a new instance from this new AMI, well, guess what? You have up-to-date, most modern box without doing anything. You just basically click the button, and you have already security covered. It allows you to have repository access to MySQL, Postgres, Ruby, Tomcat, and all of the things as a default by Linux. It's regularly updated, as I just mentioned, and it's also pre-configured with the tools to access Amazon CLI, API, and other AMI tools, which fully integrates with your AWS account, which is awesome. You don't need to do anything, just put it, and you have full access to everything on AWS, obviously if you granted permissions. So, going forward, we also have something called AWS Marketplace. It's basically an online store where you can buy a software that runs on AWS from either AWS itself or a third-party providers. And quite likely, if I'm going to show you this in a second, you will quite likely recognize lots of them. You have a Trend Micro, you have Logic, pretty much any company out there right now that is big enough to be known is already on the marketplace. You can have any solution that they're providing. You can have a Trend Micro Deep Security, for example. You can have other Logic Log Manager. You know, anything you can think of, it's probably already there. So you don't even need to build it. You just buy the solution out from them, and you can see the pricing models, for example. In here, you can see that they, for example, Trend Micro Security costs you anywhere. Sorry, that was a little bit too thick. Let me just make this a little bit smaller. You can see that they're charging you somewhere from $1.50 per hour or 8,670 for a year for the whole server. If you think about it, depending obviously what it is, it might be cheaper to go on the pay-as-you-go model than start buying licenses up front, because you don't maybe want to use you know, a specific solution for more than a few months, and you don't need to pay up front. So that's why you would use that, or you maybe even want to try the solution before you even buy it. So in this case, you can subscribe to pay per hour, use it for maybe 2 or 3 days, and then once you're done, you just basically terminate the instance and you don't pay anymore. You tried, you used all the features, you know what it is, you know if it's good for you, and if it's not, terminate, and that's it. So there you go. I have another question here from Charanjit. If we need customized package, which we need to update in Amazon Linux, is there such a provision with AWS? I would say like this: the most common scenario and situation is as follows. What you would do in this case, you can, let me go back to a few slides, you can spin up a new server from AWS itself, so basically Amazon Linux server itself, and you have my ID here. Don't worry about this ID. This ID changes every week or so, so it's always different. But if you click select, it's always choosing the most recent one. Once you have the server running, which is a pure AWS Linux itself, then you customize this server to your liking. So you install anything you want on it, uninstall anything, secure it, make sure it's got pretty much everything you can think of. And once you customize this box, what you do after is basically you create AMI out of this, which basically, if you think about it, what happened is you had an AMI here, then you spun it up into the EC2, and then you created AMI again out of it. But what it gives you is ability to take the stock AMI, customize it, whatever you want, and export this to AMI. So then, when you launch it again, EC2, you have a fully custom server that you have just created, secured, updated, and did whatever you wanted. And you can spin up multiple of those. So that will be the journey most of the time. Unless you don't want to use their AMIs and you want to upload your own AMI from your own environment, then you can. So yes. So let's skip straight into the marketplace we did. And then we also have so-called community AMIs. There are a bunch of other people out there, very smart people that really work hard, and they are very passionate about the AWS itself, and they want to contribute. They create different systems. They create ready servers for you in order so you can just launch it and play around with it. And you can actually see it in the console itself. You can basically choose OS. You can choose anything. They created a full, let's say, global telephone systems like Asterix. They created everything, every system out there, if you think about it, quite likely already exists in the community AMIs because people already created it. So there you go. I have another question from Charanjit. Who will have the responsibility for patching Amazon and Linux AWS? Is it AWS or you? No, it's a good question. Before you spin it up, before you take the AMI from AWS, it's their responsibility to patch their own AMI of their own Linux. And they constantly do this. Every 2 weeks they have a new version of security and all these things. Once you launch this into your environment, it is your responsibility from this moment onwards to keep it up to date. AWS will not come to you and update your system because they have no access to it, as we mentioned on the session number 1. So once you launch this from them, it's your responsibility. Now, if you take this instance, as we mentioned before, you create your own AMI, it is still your responsibility because it's your own AMI now. It is your custom data. So I hope I answered this. which means we need to buy support from Amazon for applying patches. No, actually, most of the time what we do is we manage our own servers rather than Amazon does this for us. In fact, Amazon doesn't have access to our data. You can manage all those servers by yourself, and that's the whole point. Once you customize anything from AWS or launched anything, it is now in your hands, in your layer of responsibility, because it's your data. They don't have access to it anymore. They own the hardware underneath, they own all the network and security, but everything that sits on OS and all the customization that you just done, it is your own responsibility. I have another question from Ravi Babu. Can we connect to party using IP that is generated? I believe that in the next few slides we will actually have that actually mentioned and how we connect to it. I have another question here from Chandra. If I need 3 instances of Trend Micro instances, do I need to buy 3 times from AWS Marketplace? Yes. In this case, if you need 3 instances that are for any reason, I think maybe what your solution here could be is you can buy 1 Trend Micro server that acts as a security box, and then you can install agents on the remaining boxes that connect to the Trend Micro server for all the scanning and all the security. Maybe that would be a better way of doing. So you have some sort of Trend Micro server as a management console, and then you install just a small, basically, daemons or clients on each other of your systems. I can see another question here. Is Oracle Enterprise Linux supported on AWS EC2? It's a very good question, Chandri. I honestly don't know. I think the list of all the supported OSs is pretty long because the versions as well have different options there. I think out of the box Oracle itself is not, because I never ever have seen Oracle Enterprise Linux out there, but I could be wrong. So I would say check documentation to have a correct answer to this question. So I'm sorry I cannot answer that. So now you can, as I said already, you can have a standard AMI that was deployed by AWS, and then you can customize AMI to your liking and save it. And we'll be showing you how to do this. So creating AMI, use an existing AMI, launch instance, customize it, and create a new AMI from it. And finally launch your instance as a server. So this is exactly what we said. So you have an AMI that is basically AWS AMI. Sorry for that, again, big font. Let me remove this. AWS. And then you launch that, and then basically you have an EC2 running here. And then once you customize this and did everything you wanted, you then create your own AMI, which is a custom. And then once you have this, you treat this as a golden image, then you can spin up any amount of EC2 systems out of it. And then you can have multiple of them anywhere else. So how we would do this and why we would do this is we would most of the time create a custom golden image for all of our systems and servers. And basically every single system and server that we launch in the future will be exactly from this build here, because we know it's stable, we know it's security patched, we know pretty much everything about it, and we know also that no matter how many times we're going to speed it up and how many copies we will create, it is always the same, which means you only patch the system once, and then you launch it, and it's exactly the same copy everywhere. In fact, what lots of people do, instead of actually, once you have, let's say, 20, 100, 1,000 servers running, instead of actually updating all of those servers individually, right? So jumping on those boxes and running maybe update, 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 what they do is basically take this AMI that they created, golden image, they launch it, basically they go all the way to the step 1, so launch the golden AMI, update it again, go through all entire process again, and create a golden image version 2. And then what they can do is they can slowly start killing those boxes and replace them with the version 2 box itself. It's much easier when you have multiple, few hundred servers, let's say, to update image once and make sure it's fully signed by security, it's fully patched, it's fully up to date, rather than do this hundreds or thousands of times. And it can be achieved basically by doing one box once. So there you go. So sorry about that. Sorry, there you go. Also, what we need to mention today is that AMI can be distributed. It can be either private, it can be either kept private, it can be shared between different accounts that you specify, or if you want, you can even publish this into AWS Marketplace and other people can use it. So you can have, let's say you have a good idea, or you're very good with Linux or Windows and you have some sort of idea for the system, you deploy the system, you convert this into the AMI, and basically you publish this as an AMI marketplace, and people can now use it, either for free if it's open source, if you wanted to make it like that, or you can specify that you want people to pay you for it per every hour they use it. And there are quite a lot of small developers and small system application owners that actually have good applications, and they basically allow other people to launch their own systems, and they charge them per hour, so you don't have to spend all this money up front, and it's easy to all the consumers. So you have option of doing so. I can see a question from Charlie. In a free trial, can we launch more than one AMI? I would say yes, you can, but the specification states that you have 740 hours of a free EC2 running per month, which means 740 hours converts to a whole month of a one T2 micro instance running. So imagine, maybe I want to have 2 instances running, but in this case, I would need to have 2 T2 micros running for half of the time in order to have this for free. Or if you want, you can have 740 instances running for 1 hour in the same time to have this free. So that's what AWS states. Now, we created AMI, and what we want to do is basically we want to remove it because we don't longer need it. So with the process of removing the AMI, we call deregistering the AMI itself. What it means is when you deregister AMI, you basically remove all the data that links EBS snapshot and EC2 instance itself, which means that the EBS snapshot will still remain in here, but you delete any record of the copy of it, which means you have no way of recreating this instance anymore. Yes, you have a server running as here, but once the server goes down, you cannot create any more copies because you just deleted basically a main copy that you created all those servers from. So the process is called deregistering, and okay, let me make it smaller. It's again getting excited, this pen. So this is it. Once you deleted the AMI, you cannot remove it. Well, if you created maybe some sort of resource from AMI like this, you can maybe take the server later on and convert it to AMI again, and that would be the way of restoring it. But there is no other way of restoring the deleted AMI or the registered AMI. Next one. Now, also, what is important to mention, okay, I have a request from Chandra regarding, can you repeat it again? Sure. When we created AMIs, basically what AMI is a collection of data and configuration that allows us to create new servers from it, which consists of EBS snapshot and also consists of other EBS volumes that are allocated to this in order for us to create EC2 instance. So basically it's a copy of a server that we can launch multiple times. So if you want to delete it, we basically deregister the AMI, which means we remove all the configuration from our configuration here, and that means that the snapshot itself will remain. EC2 instance that was actually running from it will remain, and then what happens is we can delete the snapshot itself that was used for the AMI, and in this case we will have only EC2 that was created from it, which means that deleting AMI does not delete any servers that we created. It's not. It's actually keeping them alive. It's fully independent. So that's what I meant before. I have another question from Chandra. AWS will will daily take the snapshot of the EBS volume. By default, they don't. It's entirely up to you how you want to do this. You can actually have a simple script running saying, I want to basically take a snapshot of all my EBSs, which is actually a very good idea. And it's a very good backup strategy for lots of people. So by default, AWS doesn't do this, but you can enable this as a function and make sure it's running. So another thing that is very important to mention is tags. And I really want to stress this out. Tag instances to allow easy identification and management of the AWS resources. And as I said before, imagine you have an environment that you have maybe 100, 200, maybe 500 servers running, and basically all those servers are probably members of some sort of application group or some sort of system, and you have multiple systems. Well, guess what? If you do not tag them, it's going to be difficult for you to know of what server belongs to where and even what is it for. So using tags will allow you to easily identify which server is part of which system and easily navigate between. So when you delete resources, when you create or change, you will not make a mistake. You can create your own key and your own values. You can allocate, for example, I want a key to be something like a system and the value to be maybe web system, or key to be system and the value would be a database or anything else. You can allocate key as, for example, owner, like owner and then equals, and you can have maybe charges owner of the server. So you can easily identify who to contact in case there's a problem with the system. And you have full freedom to tag all those systems and with any values you want. There's no restriction or limit on that. You can create as many tags as you want, and it will be you'll be able to easily determine that. Also, another benefit and biggest advantage of tags that I have seen in the recent probably year or so is that imagine a situation that you are running in a big organization like a multi-global company, and they have hundreds of systems running. And guess what? Each system is, despite the fact it's working for the same company, they maybe have a smaller subsections of the companies, and each subsection is paying for their own system. So they have basically internal billing for all the systems they're using. It's very common. And what would happen is AWS itself will only give you a master bill for everything running on your account, will not split it out. And you think, wait a minute, but I want my bill to be detailed maybe per system. I don't want a master bill because I don't know how much I should bill people. And yes, you can kind of calculate that, but it's going to be extremely difficult and it will never be accurate. So what you would do is you basically create a tag that you can call anything you want. I would say maybe create a tag called system equals to a name of the system, let's say DR or part of the company or something that can identify that. And all of those systems can be fully independent with their own tags. So if we have a system here that we call maybe a test, and then we have another system that we call production, you can then generate a bill based on the tags, and you can see that system that with the tag test costs, let's say, $1,000, while the production costs maybe $2,000, and that will be breakdown on your bill, which is easier for you to bill either your company or maybe your clients because you're running account for multiple clients of yours. So tags are very, very important, and it's very easy to implement, but without it, it's extremely difficult. I can assure you of that. So what we will do now is we'll demonstrate how to launch an instance and connect to it, and we're going to be connecting to EC2 instance itself. So let's start some fun. I will see if I can maybe launch instance on Simplilearn console. Obviously expired. 1 second. I will basically log out from mine. I will see if I have permissions to do that. So let me basically log out from here. Let me log in here, my courses. AWS Architects, Projects, Lab Access, AWS. Okay, if we're going to go to EC2, I think we should have some sort of rights to create something. Okay, we do. I hope we do. I don't see any errors here, which is good. So what we need to do is, let me just see, demonstrate how to launch and connect to the EC2 instance itself. So we have 0 running instances. So what we can do is we can go to either instances, and you can see pretty much nothing on the list, and we can click on Launch Instance. When we do that, we have on the left side we have navigation, my AMIs. Obviously, we have none. We have Marketplace that I mentioned to you before. You have a bunch of different systems, and quite likely there are hundreds of thousands of different systems here. So you can maybe search by the name. And you also have community AMIs that you can see. People created a few things, like they got English full containers, and they have maybe full SQL server, and they have anything you can probably think of already exists in here. So what we're going to do is go to Quick Start, and in the Quick Start, we're going to launch Amazon Linux AMI that we mentioned, that is running on the HVM, which is the hardware virtualization, and also it's running on the SSD, and that's the AMI that we're going to be spinning this from. You can see that this instance is only available in 64-bit, which means 32 is not available. So make sure that your application can support it. And what we can do is, you can see here that we're going to launch the T2 Micro because it's a free tier for us. And you can see that it's specified. In fact, it's not 740 hours; it's 750 hours. Which was my mistake. And you can use this for your testing. So let's basically next. And oh, awesome. I have no permissions to list any IAM roles, contact administrator. So okay, I don't need that in order to launch that. Let me see. We need instance, only we need one. It's not a spot instance, which I'm going to explain in a second. The VPC that we wanted to, I'm going to launch it in default. Subnet, we don't have any preference. Assign auto a public IP, I would say enable. And the reason why is if you do not enable this, you cannot connect with the instance, obviously. Shutdown behavior is stop, and pretty much everything else is stock. I'm not going to touch any of those values here. Now it's going to ask you about the root volume, which you can see is basically a 8 gigs of size, and it is a general purpose SSD. I'm going to explain all those in a second. I'm just going to basically leave everything as it is by default. I'm going to give it a name. I'm going to give it the demo EC2. And what we will do is we'll enable SSH. And what I will do personally, I will basically enable this to only be able to access from my internal IP. So I'm going to select existing security group as well. That's a default. Okay, so let's create a new security group in this case. I'm going to call it, I'm not sure if I have it right, demo security group. But let's try and see what the system will say. Okay, didn't complain so far. That's a basically breakdown of everything in here. And if I click launch, it will ask me for a keeper. Because I don't have any keepers allocated with this instance, I'll basically create a new one, and I'll call it a demo keeper. And I'll download this particular keeper, and basically I will launch the instance. And that's it. The instance is launching. You can see, if you're going to click on this link, you can see that we are currently spinning a brand new Linux server. It's a T2 Micro that we chose. It was allocated to US East 1B because we chose random. Instance state is pending because it's still basically initiating. And it's using a demo key pair that we just defined. And you can see when it was launched here, and you can see security groups. You can see much more breakdown about this particular server here. You can see all the devices connected to it, network interfaces, pretty much anything you can think of. And one of the things that you also see is the IP address, which is a public IP address that we just generated. And that's actually a good thing. So let me see if I have any questions. No, which is good at this stage, don't worry. And that's it. We just spun up a brand new instance that is currently running, quite likely still initializing, which means that it's probably still launching. It can take, the process itself can take anywhere between maybe a minute to maybe 5, depending how big the instance is and how much complexity it is to process it. Obviously, if you created a huge AMI instance, and saved custom one with loads of data on it, and I mean like maybe 200-300 gigabytes of data, it might take maybe 5 minutes, maybe 10 minutes to boot because it's a huge amount of data to process. but the empty ones like this usually do not take too long. And once it's fully running, I will be able to connect to it, and I will show you how to do it. So let's leave it running there to be fully set up. And once it's done, we'll basically connect to it. Now we're gonna do the same for a Windows server, with the exception I'm not gonna actually spin one. In fact, let me actually spin one. Why not? We can do this. We're gonna launch the instance, and you can see lower at the bottom we have a Windows server. We have a server 16. We have a server 16 with a base nano. We have a bunch of other ones. I will not connect to the 2016 yet because I still prefer 2012. So what I'm gonna do is I'm gonna launch a standard. I'm going to choose 2D Micro as well because it is on the free tier as well. I will basically choose one default, no preference, assign IP. I will enable this, and basically nothing else as standard. The default server on the Windows is actually using 30 gigs, not 8. And the reason is the Windows out of the box is probably about 20 gigs, just Windows itself. That's why it's much bigger. So we're not going to change any details here. We're going to call it demo Windows EC2. Sorry, EC2. Continue. We will choose a new security group. We will call it demo Windows SG. And to connect to the Windows, we will need to use RDP to do that, which is obviously port 3389. I'm going to only allow for my IP address. Let me just copy this. Let me view. That's a breakdown of the Windows itself. Obviously a keeper, and I'm gonna show you what's the difference between Linux and Windows. So basically, we can reuse the same keeper as we just downloaded because now we have one. If you would have more created, you would have a whole list here, and that's not for the user, that's for the whole account. Which means if any other user creates any keys, you'll be able to see it on the list here. We need to acknowledge now that you have access to this key, otherwise obviously you cannot access the server, and basically launch it. And within a matter of seconds, oh no, we have some sort of error, which quite likely means we have no permission to something to do that. And I need to again contact Simplilearn to grant us the permissions to do that. I'll be able to spin up a new instance and maybe on my own account later on if you want Windows. Let me now create an AMI. So what I'm gonna do is I'm gonna go back to the console. Let me see if I have any questions. Someone's got exactly the same error. It's AXHI has the same error as I do. Yes, it's because probably we don't have enough permissions to initiate some sort of resource, which obviously that particular error message is not very, it's not very helpful. But funny enough, if you take this error message and paste this in a support ticket for AWS, they will be able to decode it and tell you exactly what is wrong. So if you ever have a problem that you don't understand, contact AWS support, give them the copy and paste from the screen, and they'll be able straight away to tell you, hey, actually you don't have this particular permission. So that's a clue for you and a big help. So if I'm going to go back to the console itself and go to EC2, what I will do is I will basically download PuTTY. We use PuTTY basically to connect to the Linux servers, and majority of you, where is the download here? PuTTY tell yes, yes please, and also we need the PuTTY gen, and I'm going to explain why. PuTTY itself is a Windows application that allows you to connect to Linux systems via the SSH, and some of you might know it, some of you might not. So what I will do is basically I will minimize this window, I will minimize this right now, and I will go to my downloads, and I'll basically launch PuTTY. So we have PuTTY running here. But because we downloaded the key, which is in the PEM format, and PuTTY doesn't actually allow you to use PEM, you need to use PPK format. What we need to do is we will need to convert this key. I will need to load this as administrator. Starting running application. run anyway. Let me put my top secret password here, and there you go. What we will do is basically we will drag. We cannot. We're gonna load existing private key. So downloads, and basically, sorry, I need to go to System, Users, Simplilearn, Downloads, and then what we need to do is all files, demo, open, successfully imported, and now what we're going to do is we're going to save a public. Was it a public or was it a private? I think it's a private. We don't want to have passphrase. Are you sure you want to save? Yes. And then basically we can call it demo KB. And you can see that extension itself will be PPK, save. And you can see that we just generated a new key in order to access that. If you would be using any other system, like even Linux, you wouldn't have to do this. The only reason I have to is because I use Windows itself, and to connect from Windows to Linux, I need to use, unfortunately, PuTTY, which is one of the simplest forms out there. So what we can do right now is we can go to our instance that we just spun up. It's here. You can see running instances. We can see one demo EC2, which is obviously in Linux. It's fully running. So what we will do is basically we will copy the IP address, which is public, and we will paste this in PuTTY. There you go. So what we will do after that is we need to basically load the key into it. To do that, we will go to the SSH, and it's in the connection, I believe. Where was this data? Are you okay? In the username, we're going to specify EC2-user, and then we also need to load a key, which as far as I remember, is here in the text section. The key. Sorry, I need to specify the host name, session. Sorry, no, it's the authentication. My mistake again. So I will load the demo PPK key, open, and under session. Now I can basically call it as a demo EC2. I'm gonna save this, and let's see if we can actually launch it. Okay, we can see pretty much nothing on the screen, which quite likely means that we have no access to the box from security perspective, or maybe there is no internet connectivity. So let's maybe dig into it and see why. So we can see that this instance is running in the subnet, which is the default one, in the default VPC. So let's go to the VPC and see why potentially we don't have access in there. Maybe it's permissions again. So our VPCs, default one, okay, pretty much everything is in. Let's see the root table for that. Roots. You can see there is a 000/0 enabled, and it's going through Internet Gateway. But you can see the status here is a black hole, which means maybe, just maybe, someone just deleted Internet Gateway itself. So let's go to the Internet Gateways. I'm going to open this new tab. Yep, the gateway doesn't exist. So what we need to do is, well, guess what? It probably, because everyone has access here, default Internet Gateway. And I'm going to create that. We just created a demo Internet Gateway in here. And what we will do, sorry, default Internet Gateway. And what we will do is we basically attach this to the VPC. So we go to the default one, attach it, and boom, it's attached. So if we're going to go to the root table again, the one that is in our VPC for default, it's this, and then a root table, and this root table, and roots. We can now change this entry to the default gateway, and then save. and hopefully it's active, which means with a little bit of luck, we'll be able to access this instance. So let's try again. So let me load party again. Basically, we load the configuration and open. Well, we have some sort of notification. It actually says, do you want to agree to the fingerprint? Guess what? I do. And just like that, we just end up on the EC2 instance. And we are now authenticated on top of the Linux OS itself. So we can do any command we want, something like maybe ping, maybe google.com. And with this, you can see that the instance itself, because we just granted this access to the internet gateway, which was deleted by someone maybe by mistake, allows us to actually ping outside world. And obviously, this particular Google server will see us as the elastic IP that we assigned during the process of creating EC2, which is exactly here. That's the one. So there you go. How do you access Windows instance? That's actually a very good question. I can actually show you this, and how you access this. I will need to log out from my own account and log into the log out from this one and log into my personal in order to show you that. Basically, what you will use is we'll use the same keeper, but because Windows doesn't accept keepers, what you use the keeper for is to create to decrypt username and the password. And I'm going to show you how to do it. So let me log out from here. Okay, I just did. That's great. Let me log in myself. That's great. I'm going to go to EC2. Let me just see my running instance, in which VPC it is. It is VPC 1EB at the end, which is fine. I'm going to launch new instance. I'm going to launch the instance as a server 2012. I'm going to use this as a free tier again, just because we can. A number of instance 1. I'm going to launch it in the web server VPC. It's basically something that I created before, and I want to assign public IP to it. And no other changes I want to make in here. As again, 30 gigs, we're not going to change it. We're going to call it demo Windows EC2. Next, we're going to create a new rule, RDP. We're going to call it a demo Windows security group. We're going to copy the same thing in here in the description. I'm going to connect from my own IP. Breakdown, which is exactly what we want. And basically, because I don't have any of those keepers on this computer, I will create a new one. I will call it demo Windows keeper. I will download it. And I will launch the instance. Quite likely, I do have rights on this particular account to do so, so we're going to wait a few seconds for this to run. There you go. We see green window, which is always good to see. And the instance is now pending. What we will do is we'll wait for this instance to finish spinning up. The Windows itself can take a little bit longer, and I mean maybe 20–30% longer, because obviously it's Windows, it's heavier, bigger, and even the storage-wise, it's probably double or triple of size of what Linux is running. So what I will do is I will log out from this account, let it spin up, and I'll sign in to the Simplilearn account, unless our session expired, or again. Sorry about that. Jumping between accounts is not easy. So I'll log out, log in, sign in, my courses, this, lab access. There you go. We are on the correct account right now. And in EC2, what we will do is we will basically create an AMI. So imagine we are on this box that we connected before into the Amazon Linux on the Simplilearn account, and we made a change, right? So let's say we want to see where what we have here. Basically, as default, you're always going to end up in the EC2 user account when you log into the box. So if you're going to go inside, and obviously not all of you might know Linux inside out, which is absolutely fine. What will do, we'll list all these folders and files in here. We have nothing, which means nothing there. If you want to customize the box, we can, for example, create test.txt and type here hello world. I'm going to save this. And right now, if we're going to list, we have a single file that we have created in the basically our user directory called test. And if you're going to cut that file, which means display, we have text hello world. And I know it might not be the much, but exactly what you have is customization in the box. Now, you can do anything to it you want. You want to create maybe folder structure, you want to install our applications, you want to run updates. Think of anything you can do to the OS itself, either Windows or Linux, fully customize it to make it ready. And once it's done, what I would recommend to do is basically, before you take a snapshot, which is very recommended, is to stop the instance. So basically shut it down. Reason why is because when you create a snapshot and a lot of data changes, AWS cannot guarantee consistency of your snapshot because everything is changing all the time. So a part of the hard drive that is being snapshot, which is a physical replication of the drive, will consist of some data, and some other data that was overwritten after the whole process will be lost. So it's recommended to basically shut down the instance. So what I'm going to do is basically, it's actually in this case power off, and you can, I need to get root. So power off. And what happened just now, we just shut down the instance. And the instance that we just logged on this account, you can see here, it's in the stopping state, which means it's now gracefully shutting down. We did it from OS level, which means we pretty much doing everything in the graceful mode, which means it's kind of trying to close the program so it cannot hang, especially in Windows. Linux will actually be a little bit more brutal with that, but make sure you save every single thing you ever wanted. And also, before you create AMI, make sure that you clean it up, which means that all those installers that you downloaded to install application, all the configuration files, everything that you have, you actually remove, because when you spin up this whole new box, you don't want the mess to be there. As clean as possible is always the best. So now you see the instance in the stop state, which is great. So what we will do is create AMI. How do we do this? Well, you can click right button on it, and in the options here, you have instance state, so you can start the box, stop the box, reboot the box, or even terminate. I don't really want to do that because I want to create AMI out of this. In the settings here, so in the settings, you have add remove tags, you have instance types, so basically you can change what kind of instance it is. You have change termination and a few others. But the one that is actually interesting to us is under image. We want to create image. So what we do is you create image, you call, and then we have a simple form of image name and description. So let's say I want this name to the name to be demo EC2-AMI, and then you can put something like V01. So we know it's a version 1. An image description, you can put whatever you want. I will basically copy this. And worth actually mentioning that you could put in an image description maybe a date when the image was created, so you have some sort of reference. And pretty much that's it. It will have exactly the same details, so you don't change anything unless you want the snapshot to have more storage for some reason. And then you click create. What happened is image creation is requested, and it will be now created. So if you go to the AMIs, you can see now under AMI that there's a little cog here spinning on the screen in this place, which means it's processing. You can see the status is pending. You can see that when it's initiated and basically what it is. So it will give you all the information possible. Also, it doesn't really indicate how long it takes. So sometimes it's quick, sometimes it's slow, depending on how much data you have. Just because this instance was basically empty box, it should be pretty straightforward and quick. And as a part of this, you can see also under the snapshots that basically here the snapshot that is being completed is exactly the snapshot that we just created under the AMI. Now that's just being registered and should take more or less 5 minutes in order to become available. Once it is, you can then spin up the server And if you do launch the server from AMI that we just created, guess what? If you're gonna go to obviously the PuTTY one or command line, you will start the server. You will see the file that we created because all the changes are exactly there. So all the customization we've done is already embedded into this box, which is a great news. So on that, there you go. It's available straight away. I could launch this instance and show you that. I'm not sure if I want to because it's just pointless. We'll have to wait for additional 5 minutes, and I prefer to go through through the same process again. I can assure you it's exactly what we created in the demo a few seconds ago. I have a question here. What is T2 micro, large, or small? I will challenge it. I will answer this question in the next few slides because we'll be going through different types of instances, maybe more CPU oriented, maybe memory, maybe storage, and maybe even sizes. And I will show you amazing websites that you can actually see all the breakdowns and how to actually choose appropriate size instance to your system. And so I did the demo here, I did the demo there, that's good. Now, instance types, exactly what Chanjit asked about maybe 3 minutes ago. What are the instance types? And why we have different instance types? So, it provides a wide selection of instance types optimized to fit at different users' cases, and that's important. Comprise varying combinations of CPU, memory, storage, and networking, and you'll be able to choose different types for different situations. Give the flexibility to choose an appropriate number of resources for application. Also include one or more instance size to scale resources to required of a target workloads. Remember when we discussed that AWS is fully scalable, it can grow vertically and horizontally, and choosing appropriate instance size is treated as actually growing vertically, which means making size bigger. You can have a small box, you can have a medium box, and you can have a large box. The bigger the box is, more resources you get allocated, and that's vertical. Horizontal scaling is if you have the same box and you make more of those. But you can have a hybrid of those two. You can have a situation that you want maybe 2 medium boxes, 4 small, and 1 large. Why not? It's entirely up to you. It's imagination is your limitation. So what do we have? Is we have a general purpose instance type. In fact, probably 99% of the time, I use only those 3. And the reason why is most of the applications that I worked and my clients ever worked do not require specific requirements for GPU or maybe for storage or maybe of other things. And I'm going to come back to this in a second, and I'm going to explain what it is and why we use it. So we have a general purpose. It's basically in the general purpose we have a T2, M3, and M4, and those instances are kind of very, very generic. They have a good combination of memory, CPU, and everything's pretty much balanced. They have more or less equal amount of CPU versus memory versus pretty much network. So it's a little bit of everything, and it's pretty much good for everything. It's like universal instance. But then we have instances in the compute optimized called C3 and C4, and what that is a little bit of trade. So imagine you have application that is extremely CPU intensive. It performs lots of CPU tasks, and I've seen this lots of times. And you don't really need memory that much because application basically crunches through the data and basically processing everything it can. So what you can do is you can basically have a little bit less memory and have more CPU, which will actually make your application happier and quicker. So you would actually go for C4 or C3 instance types. And basically, it's used for CPU-intensive databases, web servers, applications, etc. And that's a very good place to be. So if I'm going to now go to memory optimized, I can show you this. It's an R3 instance type. It is basically used for memory-intensive databases, web servers, and applications, the ones that require lots of memory. An example here I can give you, let's say, a caching server is a very good, or even a database that is running with maybe some sort of memory cache that you want to use. And you don't want to access hard drive all the time. You want to cache as many things as you can in the memory to have as quick responses as possible. So you might want to go for R3. What it means is you will trade a little bit of a CPU, and you will trade a little bit of a storage, so you have a little bit less of those resources, but you have much more memory, which means you can utilize this to a full potential of the application. And it's entirely up to you how you're going to use it, but it's important to remember that you have such options, in which case you can allocate exactly instance that you need that is tailored towards your application to make it the most efficient, not only cost-wise, but also performance-wise. Now we have a fourth type of instances here called also as G2. What it is basically an instance with a dedicated GPU, which is a graphic card, which is used for lots of 3D applications, for machine learning, video encoding, and lots of other things. And if you have such application that you need to run on AWS, you quite likely will use that because you will use all the power of GPU, which is probably around anywhere between 1,000 and even 10,000 times more powerful for specific applications to process data through GPU rather than CPU. And that's exactly what we would like to do. I have a question here from Otis. If I have a map application, would it make sense to use the GPU for map refresh? I would say like this. I would start maybe with the CPU, so C4, or maybe general purpose, see how that works, and then see if the application that you run it's supported by the GPU here. Basically what they run is NVIDIA Kepler CUDA cores, and you need to make sure the application can utilize those via the OpenGL itself before you even spin it up. So I would say for testing purposes, feel free, but not all the applications are running, so make sure they do. And one of the last types we have is basically storage optimized family type, which means it's less CPU, less memory, but it is actually loads and super quick storage, and it's used for NoSQL databases, Hadoop, and also data warehousing, where the D2 is actually used for file system, data warehousing, and other applications like Hadoop, which means if you need loads and loads of IOPS on the drive, so you have lots of read, write, and all those operations, well, yes, you quite likely can use any of them, but the biggest advantage you will get if you're going to use optimized like D2, because you're going to have so much power and so much network that you're not going to have a bottleneck there. And that's exactly it. Most of the time what people do is they launch the general purpose, they see what the bottleneck is, and once they detected it and know what the problem is, then they allocate correct instance to it. So don't think that you are stuck with it. You're not. Play around with it, see which one is the most efficient from cost perspective, also from performance, and then choose appropriate. So there you go. And one of the last options, it's not really an instance type, but it's an option for all of them, is basically EBS optimized. What it is, it's a little tick box when you spin up any of those that allows you to accelerate your network between your EBS, so basically your data store, and your server itself. If you don't tick that, you'll be pretty much running on the standard speed of the network, which is most of the time okay. But imagine you suddenly have a database and a bunch of web servers, and the last thing you want to do is for the database to have extremely slow connection to the network drive that you're storing the whole database in it, and you don't want to have a bottleneck there. So what you would do is you would basically tick EBS volume tick, and you allocate more IOPS, which I'm going to show you later on how to do as well, and you'll be able to guarantee that the performance of the hard drive this is EC2, sorry for my drawing, this is EBS, so the performance between those two is as good as possible. So the latency is the lowest, and you can have hundreds of thousands of operations flying around this single wire between those two. If this is slow because you didn't tick it, well, guess what? You will be limited, and the bottleneck will be so big that you might have a problem with it, with the transfers and performance above a certain stage. You might not notice it at first, but when you have spikes, you will quickly notice it. So, yes, now we're going to demonstrate different instance types for in AWS. So I'm still on the Simplilearn account. We're still waiting for my Windows to boot. Quite what he already did, but I want to just go on with this. And one of the last things I'm going to show you is how to connect to Windows at the end of the session. So what we will do is basically we'll try to have a different instance type. So what we do is we go to instances, and we basically launch instance. We choose a random one. from the list because I don't really care this kind of state. And there it is. We have these different instance types. You can have here from the drop down, you can have micro instances, general, compute, GPU, memory, and storage. And also you can have a generation. You can have all generation, all current generation. What it is, as I mentioned before, there is something like a C3 and C4. C4 is the latest generation, so it's using the latest hardware, and C3 is the previous generation of hardware that they had. If you think about it, which one you should use and why? Funny enough, the latest generation always, and this is always the case, is not only cheaper by around maybe 5 to 10% that equal size server with the previous generation, but also is much more performance, about 10 to 20% depending. Which means, why would you ever want to go to C3 if you can have C4, so the latest one, and you can have not only cheaper server by 10%, but also more performant? And I would say never ever go for C3 because you actually pay more money for less performance. You always want to be on the latest hardware, so always go for the latest one you can. There are situations that you have to use C3. Maybe, I don't know, maybe rest of your application is running on the C3 and you need to just add one server. And you don't really want to add C4 because you don't want to mix the performance levels within the whole group. Maybe that's one of the situations. Or maybe you have such an old applications. I have never met them, but it's possible that doesn't actually work on the latest Intel processors for some reason. And you might want to, go to old C3 or M3 or anything you want. So there you go. The list of the instances is pretty much long, and you have different types. And I'm going to actually show you a few things. Now, I'm going to highlight here for you guys so you can see. The instance that we spun up was basically a general purpose instance, and it was T2 Micro, which had 1 CPU and 1 gig of memory. It's not much. For the demo purposes, it's probably more than we need for what we've done. So basically create a single file with hello world. That was okay. For production environments, maybe not so. So you have different sizes. You have a micro, you have a small, you have a medium, you have a large, you have extra large, and so forth. And they go pretty much in incrementals of ×2. And you can see that T2 small, for example, compared to T2 micro, has the same amount of CPU, but it has 2 gigs of memory suddenly. So you double the performance of the instance itself. You can actually ask, well, you really didn't double because you still have 1 core, but you have 2 gigs of memory. Yes, it's true. And maybe from performance point of view, you didn't really double it, but in the size as AWS gives you, you did. And next one, small to medium, you actually double everything. It's two CPUs, and then you have 4 gigs of memory. And the same applies to large. Suddenly you have 2, but then you have 8 gigs of memory. So memory went double, but CPU went, pretty much the same. So bigger you go, more resources you have, and also more expensive it gets. And I can show you an interesting website, which I will send you hopefully in a second. If you're going to type in Google AWS EC2 types, basically the website that I use a lot is called ec2instances.info. I like this website because it's clean. It's basically one sheet of the data on a single page, and I can choose lots of things. It's not AWS website itself. It's a third party. Someone created this website because they were so passionate about it, which, congratulations, is very, very good. And you basically compare instances here regarding cost as well. And you can have, let's say we just spun up T2 micro instance. I can highlight that. You can see it's got 1 gig of memory, and it's got 1 CPU. And you can see that bucket instance costs us on the Linux on demand here, costs us 0.012 cents, US cents, that's important to remember, an hour. Well, if I want to spin up a bigger one, just because I need more power, like maybe T2 small, I'm going to get 2 gigs of memory, but still 1 CPU, I'm actually going to pay double for it. And pretty much the cost always doubles as far as you go. And you have obviously different instance types. You have, like, that was T2 medium. We have M4 large, for example, in here, and this gives you 8 gigs of memory, also gives you 2 virtual CPUs, but what is actually important here, it gives you 6.5 units of processing power called ECU. and I'll highlight this for you right now. So basically, we're talking about this column here. And what is a compute unit? AWS defines a compute unit as an equal measure to more or less 1 gigahertz of CPU itself. So in this case, we can say this particular server has more or less 6.5 gigahertz of processing power, which means with the 2 CPUs, we can say it's 3.2 gigahertz each core, and that's pretty much what it is. This particular box has 13 gigs of processing power, and obviously 4 cores, and the numbers go bigger. Trust me. You can see that you have instances that, especially let me just scroll it a bit down if I can. You have instances that will allow you to have maybe up to 349 gigahertz of power, which gives you up to 128 CPUs cores. It's an immense number, yeah, but also the price you have to pay is around $13.3 every hour you use it. Well, obviously, more resources you buy from AWS, more you have to pay per hour, but quicker you do it. So if you have maybe application that requires processing power, and you don't really want to spend a week or 2 to do it, maybe it's worth launching a bigger instance, like something like this, to process everything much, much quicker and save time. Not, the cost might be exactly the same as you would run the same application for a week of the smaller instance, and maybe you're gonna finish in a day. The cost might be exactly the same, but you save yourself a week, which means it's a huge saving in time. So, make sure you understand that. Let me just see if we have any questions. Let me actually copy this page, and I'll paste this in for you guys here. I'm gonna send it to all. There you go. I hope you have this on the chat. Feel free to play around with this website. You can basically filter by memory. Maybe you want to say, I want minimum 2 gigs of memory, and suddenly only instances available here for you will actually be memory minimum 2. And maybe you want to say, you know what, I want an instance that is minimum 2 gigs of memory. I really want this instance to be cheap. What you can do is you can order this by the cost, and suddenly you can see that the instance that comes straight away in here, cost-wise, is T2 small, which gives you exactly 2 gigs of memory, and is the cheapest because you just order this by price. And there you go. You can do this the same via the CPU. Maybe you need to know how many CPUs you have, basically, and also make sure that you choose appropriate region. Reason why is lots of servers within different regions will have different prices, and I'm going to show you this straight away. So if I'm going to remove this, and I'm going to order this by the name, let's say T2 small, and we have T2 small highlighted, and that's currently the cost of the T2 small in London. It's 0.026 cents an hour. Now let's change this to maybe Mumbai, and you're going to see that you have 0.30 cents per hour. It's 4 cents US cents more expensive. You think why? Well, maybe running cost in Mumbai is much more expensive, like cooling cost and electricity and all this stuff. But if you're going to go to, let's say, North Virginia, suddenly the cost goes to 0.023, which is the cheapest. Why? Because that's one of the first data centers they created, and they have a huge amount of servers there. That's why the cost is the lowest. So it's entirely up to you how you're going to do that. And there you go. That's pretty much what we have in this particular slide. Different types I just showed you. What I will do is I will try to commit maybe extra 20 to 30 minutes to go through as much as we can before Christmas, guys, for you, before the whole break, so you can have lots of information. I hope this is all okay with you. And if it's not okay with someone, please let me know. We can maybe stop here. But obviously, I'm kind of doing this outside of the time, and I really want you to know as much as I can. And I want you to have all the knowledge and all the examples. So let me know if someone is not okay. I think everyone is pretty much okay. I see all the answers. Yes, 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 please. Okay. Great. So I will continue. So AWS Elastic Block Storage. Everyone is always happy to learn more. That's very good to hear, Charanjit. So what is Elastic Block Storage? It's basically a storage that provides persistent block-level storage volumes to use with Amazon instances. That's all it is. If you think about it, it can be something like an iSCSI. It's a basically network attached drive that you have access on the block level, which means you can have access to every single block of it. And that's it. That's pretty much explanation. And we could go into much more detail, but to be honest, it's boring and it's not needed. That's all AWS asks you to know. I have a question here from Bhavish. There is something also called elastic beanstalk. Yes, there is, and we're gonna get to this in a second in one of the slides as well. I hope, if we're gonna manage today. We have basically like this. Oh my goodness! Again, trigger happy. Again, a block level storage used to create storage volumes and attach them to EC2 instances. You use them in multiple cases. You use them as a file systems, databases, or any other block storage. In this case, you can attach it to the instance, and you can treat it as a hard drive. That's all it is. You place them in specific AZs, which is availability zone, and they are automatically replicated. You back them up as snapshots, as we will pretty much demonstrate, and they are designed to have 99.999% availability, which is quite a lot if you think about it. So basically, they are kind of bulletproof. I don't even know a single hard drive manufacturer out there that can actually guarantee more than 99.9, I think, 7% of uptime, which means that the drive quite likely will fail within 3 years for a few minutes. And you know, it's amazing number, 99.999. It's a huge number. So let's straight jump into the next slide. So we're going to discuss more. And there are two storage categories. Basically, there is a SSD backed up storage type, and here, and there's also HD backed up storage type. Why there are two? Well, guess what? We are living in the new world that SSD, so solid state drives, are taking over. They are so quick, they are so light and so energy efficient that it would be almost a crime not to use it. And you have all the benefits of extremely quick performance. You have extremely huge throughput to access the data, and extremely quick responses, like almost a millisecond, like nanoseconds almost. It's extremely quick. Now, HDD is an old magnetic type with all those spinning plates, and all of them, unfortunately, they are still good. They're still used, but they're kind of slow. And if you can have SSD, which kind of is always guaranteed by default now to all those instances, why would you ever want to go for HDD? Yes, HDD might be a little bit cheaper, and it might give you a little bit more storage, but to be honest, for the amount of gigabytes or even terabytes you're going to spin up, you quite likely never notice the difference in price. And SSD will quite likely be around 100 times quicker, at least. So, you know, we can see different types. Now, SSD itself allows you to have a provision IOPS and also general purpose, and there is a difference between them. When we use it and why? Basically, we use provision IOPS in IO-intensive, NoSQL, and relationship databases. So when we use it, is every single time you need to guarantee that your application must have the quickest possible access. And what provision IOPS is basically dedicated IO operations a second. So they give you this in the number. Maximum is 20,000 per single volume, which means you can have 20,000 read and write operations every single second on your volume. Obviously, in case you use 16 KB as a partition size. And they give you amazing throughput of 320 megabytes per second. Yes, it's not megabits, it's megabytes per second. That's insane. And also, the price is kind of medium. It's kind of, you know, it's not the highest, it's not the cheapest, but it's kind of acceptable. And you use it if you need lots of performance. Now, when you use general one, I would say use general one pretty much for everything you can, and that's my recommendation. I would kind of stay away from HDD, not because I'm not recommending this, but I used it a lot, and since I started using SSD, especially general purpose, I fell in love with it. I think the performance is so awesome, the latency and access is so quick, and the price is low to medium, which means it's not really that pricey, and you get amazing speed. There are limitations. You can only have between 1 gig and 16 terabytes of volume, to which most of you, 16 terabytes is pretty much, you will never use that. And imagine that's only one hard drive. You're going to have multiple of those connected to one instance. You can have, if you can have 20 if you want, which means it's insane. Yes, it's a little bit less performance, but to be honest, when was the last time you used 10,000 IOPS? On the daily basis on all those applications and systems, we maybe use between 300 and maybe 500, maybe pushing for very busy systems. Sometimes when you're running very, intensive tasks like maybe computation on the databases, maybe you reach like 2,000 or 3,000. 10, I've never seen in my life. Yes, you have a little bit less performance, transfers, but it's probably one of the most common ones. I'm going to put star here. Now, going back to the HDD, you do have a type of the HDD that is basically it's called ST1, which is used for big data and big warehousing. And what it is basically a collection of hard drives in a RAID array that they give you basically a big storage of up to 16 terabytes. They give you only, funny enough, about 500 maximum IOPS, which is not designed for obviously all those extremely quick applications. But what it's designed for is basically storing data for a long time. And the cost is basically low and medium. But what is good is the transfer that you can get out of this, which means if you need to process huge amounts of data, but you don't really need IOPS, then you would go for that. And the same for the cold and magnetic. Now, those are the old ones, and you can see that performance here is kind of lower and lower, and you get a really low amount of IOPS. And basically, cost is low, and then cost is the lowest, is the cheapest out of all of them. I would say most of the time I would go for general purpose. More storage you allocate, more IOPS you guaranteed, and that's simple as this. So that's the point of this slide. I have a question here from Charlie. How much the read throughput and write throughput? Which one is higher in both storages? I would say it's always higher in SSD. That's the truth. I know that you have a value of 500 here, but there is one but. You can see that you only have 500 read and write operations in case you use a volume, basically partition size of 1 meg every single time. But guess what? When was the actually last time you actually had exactly 1 meg files? Most of the time we work with the files that are super tiny, like kilobits, and in this case, this performance you would never need because you need 1 meg partition in order to do that. In this case, I would always use either of those because they give you the most performance. And once you actually start downloading all those tiny files, this 500 goes maybe down to 50 if you're lucky, because the I/O will be your bottleneck, which means this one will be much quicker long term. So I would say usually use the general purpose, which is probably the best combination of the storage you can have. And if you have a very sensitive latency-based applications like a databases or anything else, use the dedicated one if you run out of here. I would always start with this one, and if you have any problems, then switch to this one. And that's basically the truth. So what I will do is I will go to the EBS encryption. Now, EBS allows you to encrypt all the data. What it means is you can take EBS and you can basically encrypt it with your own key. And that's what we call is encryption at rest, which means all the data stored on the EBS can be fully encrypted, and the key can be kept on the AWS system called KMS. And you can have your own key created, and you can pretty much encrypt everything on the AWS itself. Maybe you need to do this for regulation purposes. Maybe you have some sort of top secret information. To be honest, there is a little bit of overhead of decryption and encryption. It's all hardware. I have to mention this. And performance degradation is maybe around 5%. So it's not that great, not that big number. So don't worry, you're not going to have half of speed. But you need to remember that obviously more encryption you use, then more overhead it will be. Sometimes you must, and there is no way of using something else. I have another question here from actually two questions from Chanjit. If in the database read request is high, then is it a good idea to use SSD? And where a write is needed, can we use magnetic storage? I would say like this. That all depends on the database itself. if your queries are massive and basically they are linked in between multiple tables and everything else, if you think about it, all of those are actually hundreds and thousands of very small requests towards different indexes and different tables and everything else, which means the requests are still small, but you need lots of IOPS. In this case, I would always use SSD, and I would not recommend HDD-backed EBS volumes for any databases. And that's the truth. Whenever you think database, always think SSD. And the price difference between those two is not much, but you're going to thank me later that the performance of SSD is at least 10, 20, 30 times more on the AWS than of the HDD itself. So there you go. Now, we have another thing called Elastic File System. And what it is and when do we use it? Well, Elastic File System is basically a file storage service for a Amazon Elastic Cloud Compute instance. What it is and why do we want to use it? Think of it as basically a network NAS server. Basically, it's a storage on AWS that allows all your instances to save data and use this data as a storage. And that's it. It's basically like a network folder that you can dump all the files and you can connect multiple systems to. I would not recommend using this as a primary source of all the OS files. What I would use it maybe for is to keep it as a central point for all your configurations, all your systems, maybe data that all the systems are using. And you can attach all of those instances to it. And once they're attached, you can basically read and write and change whatever you want. And that's it. That's as simple as that. So I'm going to show you how to attach EBS volume and on the demo right now, if I may. So we're going to go to the instance here. Let's hope the session didn't expire, did it? No, it didn't. That's good. Okay, I can, oh my goodness, someone deleted our instance, or it was deleted by itself after some time. Actually, no, it's still here. So what I will do is, it's in the stock state, that's why it didn't show in the dashboard, so 0 running instances. So I'm going to go here, and I'm going to go where we have this instance here. I see a question from Gabhari. What is the difference between EFS and EBS? It's a good question. EBS is the hard drive. It's a network hard drive that you attach directly into the server itself. And server can access this hard drive on the I/O level. So basically, imagine that you just plugged in a USB hard drive to your laptop, and you can access this hard drive like that. Now, EFS is a network drive. It's a basic network storage, like a folder, and you basically can access the data there. So think of it as your maybe NAS box or maybe your Windows file server box. You have access to the folder itself, but you don't have access to the whole hard drive, which means you cannot perform specific operations, like you cannot format it because you have no access to the block level. You can access files, but you cannot do anything else with this file, with the system. So that's the difference. So how do we create the volumes and how we attach it? So in here, in section under the Elastic Block store, basically, if we expand it, we go to volumes. And what we do is we have one volume running, which is exactly the one that was created automatically before when we spun up the instance. And here we have different basically instance types. What I'm going to do is I'm going to choose general purpose, and size of it, I'm going to choose maybe 50 gigs. And you can see straight away that this number here, number of IOPS, is actually changing. So if I choose 100, suddenly change to 300. Why did it happen? It's because for every single gig for general purpose, you will get 3 dedicated operations that you have. So if I choose 10, we will have 100 because that's a minimum number. But if I choose, let's say, 100, we will get 300. And the same if I'm going to add additional 0, we're going to go all the way to 3,000. And that's the biggest you can pretty much have. I'm going to choose, let's say, 50 gigs just because we can. We have 150 dedicated IOPS. And the important bit, and you have to remember that, the important bit is to always choose correct availability zone. If you don't do that, you will not be able to attach this particular storage to the instance. So what we do is we basically look here. I will need to close this, unfortunately, because I didn't. Sorry, no, I can see it. Sorry. You can see Let me just close it. So the instance that we spun up is running in the US East 1B, and that's important. So when we create a volume, let me do it quickly again, 50, we need to make sure that the volume is exactly in the same region, because the volume cannot be attached in the separate regions. So we choose 1B. We don't want any snapshot, and we don't want an encryption right now, because quite likely if I'm going to take this, we don't have permission to do that. So if we create one, it's going to basically provision a brand new, and let me refresh this. There you go. We just spun up or allocated a brand new volume that is 50 gigs. It's a general purpose storage, 150 IOPS, and we can see the date when it was created, and we also see that is in the AZ1B. And what we just did is just provision a 50 gigs of storage. Well, that's great. What you can see here is the storage is straight away available. If you're going to choose a bigger storage, something like maybe 1 terabyte or even 16 terabytes, quite likely you will have to wait maybe for a few minutes, because in allocating all of this storage might take some time and resources for AWS. But small storage like 50 should be available straight away. So what we do? Well, guess what? What we can do is basically action, and either this way, or we can click right button on it and basically attach volume. We have options like delete, create snapshots, and other things, but we want to attach it. Because just because we created the volume doesn't mean we attach it to any server. So what we do is we attach it. We have only one server running on this account, which is a demo EC2, which is in the stop state, which is fine with me, doesn't really matter. And then that will be the path that is attached as under Linux, and under Windows, obviously, it's going to be a little bit different. So if you attach this, great, I have no permissions to do that. Absolutely great. Sorry about that, I was not aware about that. But what would happen if I would attach this? It would basically be attached, and Linux itself would see this volume straight away. And you'll be able to format it, and you'll be able to start writing and reading data from it. And that's pretty much it. So that's as simple as this. You can see here that you have a cold HDD, and you have also called SC1, and you have a throughput optimized HDD. What it is cold HDD is used to store data, but the throughput itself is not great, which means it's used to store long-term data for cold purposes, so it's not as needed instantly as possible, but you want to store as much as possible. Basically, the throughput optimized HDD, which also is known as ST1, is the one that doesn't store as much data, but the network traffic that is basically from the storage to your instance is insane, and this allows you to copy data faster. Obviously, ST1, quite likely, so the throughput optimized is much more expensive, because network is probably much more expensive than the storage itself, especially using normal magnetic drives. But there's a difference. And if you want to store a long-term storage, you would use cold. If you want to have quick access to your data, you would use ST1. So that's the difference. So there you go. I would say like this. One of the last things I want to do is I want to show, as I promised. So I'm going to log in from this particular window. And I'm going to log into my own account. And I'm going to show you accessing Windows boxes, as quite a few requested and I was unable to do due to permissions issue. So if I'm going to do EC2s on my own account, I have two servers running. I have a demo Windows EC2, there you go, and I have my test web server that I was playing with. And I can see my instance is running on this particular IP. Yeah, that's great. So I will see if I can access this. So what I'll need to do, in order to access RDP, I'll need to make sure that I know username and the password, right? So if I'm going to do remote desktop connection, and I type my server IP that I just copied from the public IP and try to connect, it will ask me for my credentials. Well, what are my credentials? I don't have them, right? All I have is a basic demo Windows kp.pem, which is basically encrypted key. So how do I do that? Well, in Windows, what you do, you can click right button, and basically you have option here, get Windows password. And what you do, you basically, it will say, I need the demo Windows KP the key itself that I spun up this box with. So all you need to do is basically choose demo Windows KP, open that. That will be basically an encrypted key. And once you uploaded that, you can decrypt the password. And suddenly you see that you have a server here with IP address, administrator, and the password, which means that credentials for this box, when it's spun up, are actually sitting on AWS. So what I'm going to do is I'm going to copy that. I'm going to switch to my remote desktop. I'm going to type administrator here, administrator, and I'm going to copy my password. And what we might see, oh, I think I mistyped something. More choices. I think I mistyped the username. That looks better. I cannot even spell. There you go. What happens is now it will say, hey, are you sure you want to connect to this box? Well, yeah, I kind of do. So what happened is we have a black screen, which is fine. Windows is loading the desktop. Now, the Windows we chose is a T2 micro box, which is extremely small, so might be at first a little bit slow when it's setting up the profile. Once this is done, which might take a few seconds, so no worries, it actually will happen eventually, as you see. And we are on the box, basically, and it will go into the profile itself, and you'll be able to see the desktop. And that was as simple as this. So the difference between Linux, and let me minimize this and let it run in the background until the desktop is ready. So the difference between Linux and Windows is that in Linux, you don't have this option because it's not a Windows box. You need to use the key that you generated, and in Windows, because Windows doesn't use this key, you need to get Windows password, and that's how you're accessing it. So I hope I answered your question. It's still doing something. Come on, I want to see the desktop. Come on, Windows. You can do it. Let's wait a few seconds here for it. Okay. So basically, what we just did. Damn it, my bar doesn't want to hide. Toolbars. Oh, damn it. Settings. Hide taskbar. There you go. Boom. As you see, suddenly we are on the Windows box. You can see here from the logo we are running Windows 2012 R2. In here, in theory, once if I have correct resolution, you will be able to see all the host name and everything that AWS allocated. You can see T2 micro in here. Let me just draw it for you. Sorry. You can see that instance type is T2 micro. It's EU West 1C. You can see private IP address. You can see public IP address, and you can see also instance ID as well as the host. And basically, it's just a Windows server. You can do anything you want with it. You want to access internet? Well, guess what? You can. And you'll be able to do that. Let me wait for... okay. I see that enhanced security is enabled. So to disable that, we need to go to the server manager. Not that I would encourage you to do that in the production systems, but just for the purpose of that, in the local server, in here, advanced, it's on. I will disable this, off. Okay, I will minimize this. I will close that, and now I need to reopen that again. Otherwise, we won't be able to see many websites, and you will have to click multiple times, like agree. So come on, Windows. You see, because the instance is a little bit small, a T2 micro with only 1 core and 1 gig of memory, it's a little bit slow, and I wouldn't really recommend running T2 micro for production Windows boxes because it's not really performance. And boom, we have internet straight away. We can access internet, we can download applications, and you can do other things. And if we're gonna go for Task Manager, there you go. You can see pretty much Task Manager all the performance of the box. You can see that we are using about 20% of CPU, pretty much doing absolutely nothing on this box. We use 0.9 gig of memory, so 90%, and we don't even have anything running on this box, which is purely Windows doing something. We have users, basically 1 user, and we can see that this user is using Internet Explorer is using 6%, which doesn't actually, nothing happens on this website. It's already using 20, almost sometimes percent of CPU, which means obviously the box is a little bit too small for production environments, but for the testing purposes, it's more than you need. So there you go. So thank you so much for today, and see you soon.